This conference will now be recorded.
Hello everyone, is my voice clear?
Hello. Yes, it is.
Thank you for the confirmation. Sorry for the delay, this is due to some login issues. Just now sorted it out. Well, since I hope everyone is here and we have a lot to cover, we really should begin today's webinar. I really appreciate you all for attending today. A very good morning, afternoon, or evening to one and all present here virtually with me today. Let me introduce myself. My name is Sarah Williams, the conference organizer for the conference organized today. I'll be available for any of your queries or questions throughout the webinar to help out technically and organize the webinar successfully. For the next 5 minutes, please allow me to give a brief description about our organization, Coalesce Research Group, and also the further instructions. Coalesce Research Group is very delighted to welcome you all the speakers, supporting associations, students, and delegates present virtually with us today. With the aim mark the scientific excellence by facilitation, conversations, sharing knowledge, Coalesce Research Group follows through the objective of setting standards in delivering excellence in the research among the researchers, academicians, and industries. We also hope your participation will contribute to new research findings and that will lead to new collaborations and research initiatives. Before we start with the sessions, I guess some of you will be new to the GoToMeetings app. Let me just explain you the important tools required for the presentation. On the GoToMeetings app or web page, you can find four icons at the bottom center, that is mic, camera, screen, and end. The mic button, click on that to mute or unmute. I request you all to stay muted while other speakers are presenting their work so that it does not cause any disturbance to them. Camera, you can use this button to share or unshare the webcam. If you have the option to share the webcam, you can do it, or and it's completely your choice. Screen button, you can use this button to share your screen. This is the main part. During your presentation, after I announce your name from my side, I'll be making you the presenter and I'll give you the permission to share your screen so that you can share your PPT and present the talk. So once I make you the presenter, you can click on the screen button and you will find a pop-up window to share your screen. End button. This is your fourth icon where you can use this to leave the session. On the top center, you can use the options to change your display settings. At the top right corner, you will have three icons, people, chat, and settings. In the chat option, you can chat with me or any other participants. So let's start our session with the presentation by Wei Huang from Sichuan Agricultural University, China. The presentation title is Does Family Care Promote Clean Cooking Energy Choices for Older Persons? Analysis in Light of Home Based Care in Rural China.
Okay, thank you for your introduction.
I have made you the presenter and you can share the screen now.
Uh, Hello, everyone. Can you hear me?
Yes, we can hear the voice and we can see your slides.
Okay, thank you. Uh, Good morning, everyone. Okay. My name is Wei Huang from Sichuan Agricultural University. I'm honored to have this opportunity to present my thesis to you. The title of my thesis is Does Family Care Promote Clean Cooking Energy Choices for Older Persons? Analysis in light of home-based care in rural China. I will start today's presentation with the following four aspects. The first part is the introduction, ensuring access to affordable, reliable, sustainable, and modern energy for all is
నేను రాజీవ్ రాజేష్ పొట్టు పొట్టు తిడతాను నేనైతే నువ్వు ఏమన్నావు అంతే
one
కదా
of the United
కాకపోతే ఎండింగ్ ఏం పెట్టారంటే
Nations Sustainable Development Goals. However, 675 million people continue to be without electricity, and 2.3 billion people still burn fuels that are harmful to the environment. One study stressed that indoor air pollution from fossil fuel combustion resulted in approximately 23.1 million premature deaths, with 1.26 million deaths occurred in China.
एक
This
मिनट
shows that
सस्ते लोग
cooking energy transition has become an important topic that needs the world's attention. By combing through the literature in related fields, it can be found that the related research mostly focuses on two aspects: the discussion of care for the aged and the exploration of vectors of transition in fields. Next shown is the theoretical framework of this article. The theoretical framework of this article is based on Ford's behavioral choice model. This model indicates that the emergence of a behavior depends on three elements: motivation, ability, and triggers. The subject of research here is cooking energy choice behavior, which explores whether older adults choose traditional polluting or new clean energy for cooking. The variable at the ability level is feasible ability. This concept was first developed by Amartya Sen, a development economics and a Nobel Prize winner. This paper follows this concept. Specifically, this paper first uses the entropy power method to synthesize willpower, and then uses this method again to synthesize physical power, willpower, and economic power into a composite indicator. This composite indicator refers to the ability to adopt new clean cooking energy. The motivation explored in the paper mainly takes into account old people's motivation to fit in, that is, to use the same energy source as the people allow them. Possible marginal contributions of the article are: firstly, it combines the energy transition with the problem of aging. Secondly, introduce Ford's behavioral choice model from psychology to energy transition field. Thirdly, it explains the mechanism of the impact in detail. The second part is the methodology of the article. The data of the paper comes from China Health and Retirement Longitudinal Study 4, a large-scale interdisciplinary survey project jointly executed by Wuhan University and Peking University. It's of wide coverage, comprehensive, and authoritative. It utilizes multi-stage sampling with PPS sampling methods at both the county or district and village sampling stages, and the data are highly representative and authentic. The sample covered all provincial units in mainland China, excluding Tibet. The survey targets middle-aged and elderly people aged 45 and above. Its survey content involves variables related to the health of the elderly and the economy of the elderly family, so which can provide data support for the empirical research. So the cross-sectional data of 2018 was chosen after cleaning work such as variable selection and outlier treatment. 6,180 sample data were finally retained. Next shown is the variables of the paper. The explained variable is CC, which refers to clean cooking energy use. It's a binary variable. The core explanatory variable is carefully aged, according to who provides the resources for the elderly. Carefully aged can be categorized into social care, family care, and personal care. In China's general situation, living with one's children, who are the main providers of the financial resources needed by the elderly, can be regarded as family care. Social care and personal care can be defined in the same way. Since there is little choice in the use of energy by the elderly with social care, it's outside the scope of this paper, which examines only the situation with family care and personal care. Among the control variables, the article includes variables for the personal characteristics, family characteristics, and some dynamic variables to include location. Finally, there are moderator variables. The moderator variables contain two dimensions, which are ability and motivation. As mentioned earlier, the variables in the ability dimension were synthesized by using the entropy power method twice. The variable in the motivation dimension is neighborhood effect, measured here by the average expenditure on non-clean fuels by other households in the same community. Then comes the model setting for the article. Since the explained variable is a binary variable, so we use the problem model. The first moderating effect equation introduces an interaction term between the explanatory family care and the neighborhood effect. In the second moderating effect, the paper switched the explanatory variable from family care to personal care, introducing an interaction term between personal care and ability. Both models are centered. The third section presents the results and discussion of the paper. The results of the baseline show that the family care has a negative impact on the adoption of clean cooking energy. Since a problem model is used, we also report marginal effects. At the average level, controlling other factors unchanged, the likelihood of adopting clean cooking energy decreased by 8.5% for older adults with family care. The results of heterogeneity analysis showed that both the negative effect of family care and the positive effect of personal care are more pronounced in male groups and older age groups. Next is the moderating effect. The coefficient of the interaction term between family care and neighborhood effect is significantly negative. which indicates that the neighborhood effect strengthens the hindering effect of family care. The coefficient of interaction term between personal care and liability is significantly positive, which indicates that visible ability strengthens the positive effect of personal care. The fourth part is the conclusion and the outlook of the article. The conclusions of the paper are: firstly, the family care for the aged is detrimental to the utilization of green cooking energy, while personal care promotes the utilization in contrast. Secondly, the impact of home-based care for the aged are both more pronounced in the male group and the older age group. Thirdly, the neighborhood effect significantly enhances the adverse influence of family care, and the visible ability significantly reinforces the beneficial influence of personal care. Then comes the policy recommendations. Firstly, clean energy promotion and support policies in rural areas should focus more on the elderly. Secondly, we should consider the special impact of home-based care on the promotion of use and the use of clean energy. Thirdly, attention should be paid to the role of neighborhood effect. From the perspective of research, future studies could focus more on clarifying the impact of different types of care for the aged on the adoption of different energy sources. A more comprehensive empirical study could also be carried out by conducting a wider range of household surveys. Finally, I would like to thank Professor Hao Yang, who guided me in conducting my research in economics, Shu Li and He Yang, who worked with me to complete the paper, the major program of National Fund of Philosophy and Social Science of China for their financial support, and the anonymous referees and editors for their reviewing and critical comments. In addition, we would like to express our sincere thanks once again to the National Development Research Institute of Peking University for providing the data. This is the end of my sharing. Thank you for listening.
Thank you for your presentation. Any questions?
Okay, feel free, and further communications will be welcome.
Okay, thank you once again for your presentation. I hope there are no questions.
Thank you for your introduction.
So we are moving on to next presentation by Alan Tatalovic from HEP ODS Electroprimeros Rizeka, Croatia. The presentation title is Hosting Capacity of Distribution Grid.
Hello,
Hello,
good afternoon.
good afternoon. I have made you the presenter. You can share the screen.
Thank you. Can you see the presentation?
No, we didn't see your presentation. You need to open it.
Just a second. Now can you see the presentation?
Yes, we can see the presentation now.
Can I start? Can I start? Do you hear me all?
Yes, your voice is clear. You can start.
Okay. Good day to all esteemed participants of this conference being held here in Prague over the next 2 days. First of all, I would like to thank the organizers for hosting this professional gathering. Let me introduce myself. My name is Alen Tatalovic, and I came from Rijeka, Croatia, where I work as an engineer at HEP ODS DO Elektroprimerje Rijeka. My role involves designing distribution networks together with Mr. Vitomir Komen. I have prepared this paper on the topic of determining the share of distribution sources, um, the potential pathway of modernization and development of existing networks. To start, I would like
Can
to
you
briefly.
please change the slides while you present because we are able to see only the first slide.
Uh, you don't see my next slide.
Yes, you need to click on number 2 for the second slide. Every
Not in
time you need to
presenter
click
mode.
on the slide.
U krivom modu si stavio prezentacijski mod.
Di se to promijeni?
Gore lijevo imaš gdje si biro modove, kad imaš modove prikaza ekrana, staviš prezentacijski mod. Zato imaš dva ekrana. Ili mijenjaj manualno ovako, stišći jedan po jedan.
Pa mislim, mijenja manualno, ne znam da li se vidi sve.
Ne vidi se ništa, blokirano ti je na početnom. I spoke with the colleague in the Croatian because I'll try to help him.
Znači, samo malo, ima prozor, ima cijeli zaslon.
Tako je cijeli zaslon odaberi.
Znači, cijeli zaslon.
Evo ga, kako imaš dva ekrana, sad odi u tom zaslonu otvori prezentaciju. Ako pomakni ga na taj zaslon, ako ti nije na tom zaslonu prezentacija.
Ovako, da se sad vidi.
Tako je, i sad odi na F5 da ti pokrene.
Ok.
Sad se vidi, sad promijeni.
Sad se vidi, jel?
Da, sad odi promijeni slajd. Evo ga.
Može ovako. Hvala puno.
That's perfect. You can start.
Okay, thank you so much. Then I will continue from the second slide. To start, I would like to briefly present my work on determining the share of distributed sources in distribution networks. To make the presentation as comprehensible as possible, we will first look at the problem that prompted this research, followed by a comparison of traditional and modern distribution networks. We will then explore a modern distribution network with distributed sources and their impact, review the limitations in the parts of the network, and discuss the methods using in calculating network capacity. The presentation will highlight the application of the Monte Carlo method, which is an iterative procedure used to determine maximum share of distributed sources. This will be demonstrated through the real-world example of distribution network, and in the end, I will discuss the results and present our conclusion. Distribution networks evolve over time, and new challenges arise for their planning and development. Today, we are witnessing an increasing use of renewable energy sources at all voltage levels, which arises and the issue of integrating these sources into distribution voltage levels. To address this challenge theoretically, we developed this paper. To approach the solution effectively, several aspects had to be considered. the basic structure and elements of distribution networks, types of distributed sources, and the technical requirements and the impacts these sources have on the network. Since calculating power flows is very complex, it's crucial to select the appropriate method to determine the maximum share of distributed generation and validate this with the real network example. Here you can see modern distribution network. Modern distribution networks differ significantly from the traditional counterparts, which we predominantly they were passive, and they have the only flow of the electricity in one direction, that is from generation to consumption. The integration of renewable energy sources in the power system has introduced two direction of the power flow, and that's significantly influencing on the network behavior. This shift from one direction to two direction power flow bring some positive and some negative changes to the networks. One of the major changes associated with the bidirectional power flows is an issue of microgeneration at household level, which is often deeply embedded in the grid. This possesses significant complications for overall management and stability of the network. Renewable energy sources are now being connected to power grids at various voltage levels. Due to additional subsidies from European Union, more consumers are installing renewable energy systems, particularly micro systems with capacities up to approximately 10 kilowatts power. Larger consumers, such as businesses, are higher energy demands and installing systems up to 5 megawatts. Moreover, there are even larger plants that need the capacities reaching up to 300 megawatts. As I said earlier, the integration of renewable sources deep within the network results is electricity being exchanged in two directions, and then this dual power flow brings both a positive and a negative impact. Some of the positive influences or impacts are increased reliability of the power supply, reduction in energy losses, decrease in voltage drops, improvement in quality of power supply, and on the other hand, there are also a negative effects, such as changes in voltage levels due to fluctuation of the power flow, complications in power flow calculation, transient phenomena caused by frequent switching operations on and off, increased short circuit currents, which can affect in protection systems, and network congestions, especially in certain sections of the grid. To maximize the benefits of distributed sources while minimizing the negative impacts, it's essential to employ network optimization techniques. The goal is to integrate as many distributed sources as possible without breaching the network's operational limits or criteria. Several methods can be used to optimize network performance, including OLTC transformers, reactive power control, static and dynamic network configuration, use the special devices in network management, and so on. In this case, we employed the active network method, which leverages distributed sources for optimizing the network performance. In distribution networks, the addition of generation at consumers' premises introduce bidirectional power flows that complicate standard calculations. As generation is added at various nodes, different production scenarios arise. necessitating to use stochastic methods for powerful calculation. Given the complex of the calculation and the variability of generation scenarios, stochastic methods are ideal for determining the maximum capacity of the network node, also as known hosting capacity. The process begins with the input data. Input data about the network, followed by defining the constraints that needs to be satisfied, and then executing the algorithm. The algorithm iteratively increases the power until one of the criteria is violated, thus identifying the maximum permissible distributed generation capacity and the power. The Monte Carlo method is widely used iterative technique in numerical mathematics for scenarios where outcomes are uncertain. In the context of renewable energy sources whose production is unpredictable, the Monte Carlo method is ideal for calculation of maximum share of distributed generation. During each iteration, the unique scenario is generated. The method involves adding a maximum production capacity while altering the fundamental criteria, such as thermal limits of lines and equipment and voltage limits within 10%. The algorithm operates, you can see on the right side, there is a picture of the algorithm. It operates on the principle of generating a hypothetical 10 kilowatt generation with a maximum deviation of 1 kilowatt, which is represented on the Gauss distribution that you can see on the left side. For example, this could represent production of solar panels installed on the roofs of the households. The algorithm then places the generation unit onto a randomly selected bus within the network and calculates the power flow. For each iteration, production is incrementally increased until one of the criteria is violated. These criteria include line loading, transformer loading, and voltage limits. Once the algorithm calculates the maximum distributed production for the particular scenario, it repeats the procedure for a specific number of iterations, representing different production scenarios. The greater the number of iterations, the more accurate estimate of maximum distributed generation or hosting capacity that the network can accommodate. To apply Monte Carlo method in a real world, in a real network scenario, it is first necessary to define the input data related to the network and the parameters of the algorithm. The real network used in this case study is a classical radial network operating at a low voltage of 400 volt, connected on a 40 kilovolt amperes distribution transformer. The network consists with 47 consumers with total consumption of 377 kilowatt, distributed across the 5 radial feeders. The Monte Carlo method parameters include 1000 iteration, with each production unit having a capacity of 10 kilowatts. The slide on this slide, you can see the picture of the real network. It showcases a layout of the radial feeders, positioning of the distribution transformer, and the distribution of consumers within the network. This visual representation will aid understanding of the impacts of distributed generation on this specific network setup. To accurately perform the calculation, specific criteria must be set to determine when the algorithm should halt during each iteration. For this particular network, the following limits were established for line load up to 95% of nominal power and the current that cable can accept. Transformer load up to 100% of its power capacity, and the voltage limit must remain within 10% of the nominal value. Additionally, since we are considering two scenarios, one where the return of electricity in the grid when the case is for able and one for unable. In the first scenario, where the return of electricity to the network is disabled, there are results for maximum installed power of 397 kilowatts, minimum installed power of 256 kilowatts, and the main value for 1000 scenario is 387 kilowatts. Key observation include the significant reduction in line loading and transformer relief on more than 99%. There is also a voltage increase of 1.5% and the reduction of line losses by 85%. The algorithm concluded that under this scenario, 38 produces with the average capacity of 10 kilowatts power could be connected to the network without violating any constraints. These slides present the output data from the simulation. On the left side, we can see the maximum generation capacity, and then can be connected to the power. While on the right side, you can see the chart that displays the criteria that mostly and frequently led to the suspension of the simulation. In majority of cases, the budget was held due to the constraints related to return electricity to the grid, followed by line overload criteria. On the other hand, for second scenario, where the return of electricity to the network was enabled, the results are as follows. Maximum installed power was 811 kilowatts. Minimum installed power is 203 kilowatts, with the main value for 1000 scenarios of 623 kilowatts. In this scenario, the initial sections of the feeders experience relief, while lines closer to the customers were heavy loaded. The transformer is relieved by 46%, and the voltage increases by up to 9% of the nominal value. Line losses are reduced by 25%, and the algorithm determined that 59 producers with the average capacity of the 10 kilowatts each could be connected without exceeding the constraints. Similar as the first model, these slides also show the output data from the program. On the left side, you can see the maximum generation capacity that can be connected on the network. On the right side, you can see the diagram that indicates the criteria that most often cause the suspension of the simulation. In this case, line overload was the predominant limiting factor, followed by transformer overload and the line constraints. At the end, the distribution networks are evolving rapidly with increasing integration of distributed generation. As they transition from passive to active networks, managing bidirectional power flows become more complex, making it challenging to configure the protection systems. Distributed generation in small nodes brings several benefits, such as reducing the load on the lines and the transformer. In this study, we examined the real network with total consumption of 377 kilowatts under the two different scenarios. First scenario is island operation mode, when the electricity return to network is disabled, the maximum generation capacity was calculated as 387 kilowatts. And on the other side, active network mode, when the electricity return is enabled, the maximum generation capacity was calculated 623 kilowatts. Overall, the distributed generation has positive and the negative impacts on distribution networks. In our responsibility as network planners to maximize the benefits while minimizing the drawbacks. Encouraging the green energy from renewable sources is essential for production clean energy and preserving our planet for future generations. Thank you for your attention. I hope you found this lecture informative and engaging. You can ask if you have any questions.
Thank you very much for your presentation. Any questions?
Teo, hvala puno na uputama za ovu prezentaciju.
Ma ništa, nema problema.
There is no question.
I hope there are no questions. We are moving on to next presentation now. The next
Thank you,
presentation is
everyone.
by Mateo Kirincic from University of Rijeka, Croatia. The presentation title is Aspects of V2Z Implementation in the Distribution System.
Hello everyone. Can you see my screen?
Yes.
Yes, we can see the screen.
Okay, thank you very much. My name is, hello everyone, once again. My name is Mateo Kirincic. I'm the PhD student at the Faculty of Engineering at University of Rijeka in Croatia. Today I will talk in my presentation about the aspects of vehicle-to-grid implementation in the distribution system. The breakdown, let's say like that, agenda of the presentation is set up like this. So it is a short introduction about the starting point. Then we will talk about the starting points for the thinking and the baseline of the discussion. Then we will have the approach which is taken. Then a couple of words about the grid to voltage to vehicle system and vehicle to grid system, the benefits and auxiliary services that are the outcome of the system, and at the end some conclusion. As a short introduction, we all know that we live in an extraordinary dynamic and exceptionally challenging time in the energy sector, which is very interesting on one hand and very fruitful as the technology progresses and as everything evolves. But on the other hand, it is very challenging for the technical side of the grid and everything to be handled and set up properly. Then we have a lot of new technology implementation and a lot of advancement progress within the technology, which are the challenges itself. Then we have the continuously growing presence of distributed energy production, especially from renewable energy sources, like colleague from Croatia talked in the previous presentation. And then we have the conventional transport and mobility transformation that is in transit to electricity-powered vehicles, which is on our one hand very good for the progress and the environment and the efficiency, but on the other hand creates a lot of pressure and a lot of, let's say, operational aspects that has to be taken care of from the technical side of the grid aspects. So as a starting point, I set up this on the right side. You have the image of the conventional energy grid topology, which is in a centralized way. It is the unidirectional energy flow from the top-down fashion. So we have some generator power plants far away, then to the transmission system, to the distribution system, to the end user customers. It's a unidirectional energy flow that brings us the predictable energy consumption, the grid stress level, and the grid managing and monitoring techniques are familiar because it is developed over the years of usage. And on that data setup and experience, we can have the predictable future grid building and maintaining investments, which are the key part of every DSO. On the other hand, like again, my colleague Alan said, we have more and more growth of the distributed energy resources that makes the centralized system on the previous picture decentralized. Like you have a comparison on the right side image. The decentralized energy production brings the bidirectional energy flows within the grid. It makes more complex the energy managing and monitoring techniques and the monitoring and managing the grid itself. We have the more complex energy consumption and grid stress level calculations, and we need a serious energy grid adjustment to be capable to withstand the same standard security and stability of the grid. As well, we need new technology implementation, and new energy market participants are the side product of decentralization as well. One of the also big hits, let's say like that, is the constantly growth of the electric vehicles, or the EVs, popularly called the greener transport solutions, the transition to greener transport solutions. As I said, it is also additional stress to the existing energy network, which is developed in another fashion and another way, and now has to be recreated or updated or reconstructed in several parts of it to withstand the new impulse of the EVs that are pushed up to the grid. We have the adequately growing number of EV charging stations as well, and consequently growing energy demand and additional pressure on existing energy infrastructure. It is a more challenging energy grid monitoring and management as well, because the stability and reliability of the grid is key. Here is just a representation of the additional energy load that are brought through the EV charging. So we have the base consumption over the 24 hours time schedule. You can see in red the EV charging peaks. So the previous peaks in energy load are now even pushed further up. So now we can, from the starting point we talked about, we can let's say bring out some of the baseline and the challenges that we are facing. So one of the biggest challenges to withstand the rapid energy pressure increase of the existing energy grid as a result of new technology application in everyday life of the consumers. For instance, the EVs and EV charging stations, they are being created and built all over the country and all over the grid, essentially, and over the world. That is especially reflected on managing and monitoring side of the distribution grid, where the implementation level of monitoring and grid stress level equipment is lower than in the transmission system grid, for instance. Therefore, when we combine it also with unreliability for energy production from renewable energy sources and the common change of energy flows in the grid, we have growing expenses in investments and maintenance and predicament of the monitoring of the grid. So, what approach can we take to turn the tables around? So, we can take the additional use, for instance, of the electric vehicle and electric vehicle supply equipment beside its primary use as a way of transport. So, actually, if we look at from technical side, the electric vehicle is actually the batteries on wheels. So if we use the battery capacity in EVs as an additional storage capacity of electric energy, and we take the additional battery capacity, we can use it as a new source of energy or as controlled energy load if we took the right system and the right principle. It can help as well maintain the balance between the demand and supply, and it can also contribute to flexibility, stability, and reliability of the grid as the end result, which is the key point of this approach. It can be done through right implementation of grid to voltage or vehicle to grid system, as we will discuss later in the presentation. So G2V or grid to vehicle actually represents a concept that optimizes and schedules charging of EVs in a smart way. It controls the rate of the battery charging and it adapts according to the demand of the grid. It's a unidirectional energy flow, so from the grid to the EVs, but in some way it is similar to conventional way of charging, but the difference is in process that is optimizing and smart scheduling according to the grid demands. So if we remember the previous slide, when we have the peaks of the charging that is existing, the peak load, we can now postpone it and reduce it in some way to have the more balanced grid. On average, also one key point fact is that the EVs are unused for 90% of its lifetime. So G2V, it can provide auxiliary services in sense of working reserve and grid control. They can provide and improve the grid flexibility, and it can help reduce peak loads of the grid, as I said before, and it can make additional income possibility through right market incentives for the EV owners. This is just a schematic representation of the G2V system. From the left side, you have the grid that is unidirectional way through the charging station and at the end to the vehicle. If we take the G2V concept and think of the way what can we make better, we can make it bidirectional. So we can upgrade it and make it a vehicle to grid system. So let's say the vehicles can give the energy back to the grid. So the vehicle to grid system represents the concept of bidirectional energy flow between the electric vehicles and the grid. It allows electric vehicle to control the rate of the battery charging, but also to supply the energy to the grid on demand. The ability of the EVs to return the energy to the grid on call is especially important because then the vehicle and the load, they can participate in auxiliary services. Altogether, contributing to added flexibility, stability, and reliability, as we said before. And it also allows the end user to participate in the market now, not just as a consumer, but also as a vendor or as an active participant through the aggregators and the additional energy possibility on the market. It also creates opportunities for new energy market participants, as I said. So this is the schematic representation of the vehicle-to-grid system. It is basically very similar to the previous, to G2V, but just upgraded, so we have additional energy flow in the opposite way that demands more technology and monitoring and, let's say, exchange of information between the parameters of the grid. Vehicle-to-grid system is generally consists of a distribution grid, DSO, aggregator, bidirectional charger, and electric vehicles. So the constant exchange of information between the system components is required to provide the safe, reliable, and stable service. Here is the schematic representation of an information exchanging process within the vehicle-to-grid system. So we have the distribution system operator, which handles the first requirements from the distribution system, likewise like frequency, load, capacity, or voltage. Then the DSO talks to the aggregator, or the aggregator they exchange and set up the charging and discharging plan, and they are constantly monitoring the data. And then the aggregator, on the other hand, is in line and talking to the electric vehicle owners and the end users, and they are setting the state of the charge limit, the maximum charging current requirement, and of charging and discharging. And this way, through the aggregator, the vehicles and it can be used additionally to sustain the electric energy grid and to help the DSO optimize and balance and the usage of the grid. So vehicle to grid benefits and services. Main benefits and advantages of the system itself is the ability of providing bidirectional flow of the energy between EVs and the grid. It allows providing auxiliary services to the grid, such as reducing the peak load, voltage regulation, frequency regulation, controlling the energy load, and providing working energy reserves. Also, it can increase stability in the domain of the renewable energy sources, and it creates new opportunities for the energy market participants. This is just let's say, showcase of how the system can help and to sustain and balance the load curve. So we can see in orange the, let's say, postponing of the G2V system and the postponing of the and balancing out the stress that has to be the electric vehicles being charged. And then we have from the peaks of the vehicle to grid system that are reduced through the bidirectional energy flow that can be optimized. In conclusion, the implementation of new technologies along with rapid technology progress is bringing new challenges to the energy grid in planning, operation, and maintenance. Integration of electric vehicles and electric vehicle supply equipment into a conventional energy grid is a prime example of that. On the other hand, the new technology implementation, such as V2G system, represents safe and solid response to constantly increasing energy demand. Possibility of bidirectional energy flow and its utilization in form of auxiliary services of the energy grid. And this all together is a big added value in flexibility, stability, and reliability of the energy grid. And that was all from my side. If you have any questions, shoot.
If I may ask a question, Stefan Harkma from TNO. I'm curious about the amounts of electrical vehicles you would need in order to make this work, and if this technology is already actively pursued by any of the OEMs?
It is actually being tested because the approach of installing the electric vehicle supply equipment is for now in the, let's say, there are several additional aspects that has to be taken care of. One of it, it is being now tested and implemented to some of the systems in Europe. The electric vehicle supply equipment, as I said, it's tricky because for now it is being the part of the charging station, let's say like that, itself. But if there are also from the electric vehicle manufacturers, they are now trying to incorporate it within the electric vehicles. So the vehicles, when they come out of the factory, they will be ready to be the participant or in such a case, such a system, let's say like that. Additional problem it creates, it's what is the right, let's say, return amount of the money, for instance, to the end user owner. For instance, because if you use the capacity of the electric vehicle, the battery, you are cutting short on the life cycle of the batteries because with the usage it deteriorates the battery life cycle. So it is also an important keynote that has to be taken in care to, let's say, have a fair price of the for the end user and then for the grid side management as well, and to be also flexible as well. For now, you have to have a large amount of vehicle to make let's say, bigger impact. But if you take, for instance, in Croatia, we have not big cities like in other, let's say, parts of the Europe, but for our, let's say, perspectives, for instance, in Rijeka, there is a very little parking space. The city is not too large and it's very good with the public transport connected. So you could have uh, um, you could reduce the traffic and the amount of the vehicles that are just day-to-day basis if they're electric, and you can predispose them on the several locations that are good for the grid, let's say like that. So you can make the impact that is wanted for the grid and for the people. So for
Hmm.
the DSO on call, and then on that is mostly on the public structure, especially for instance on the island of Kirk, where I'm from, we have a strategy made that 58% of our, let's say, CO2 pollution is from the transport. So if we as an island, let's say, transition to the fully green transport way, and then sustain it in this way from the renewable energy sources that we have also good capability of, and from the grid management, we can make that work, let's say, from the technical side as well, and from the grid side as well. It is a lot of components that make the unity flexible.
Hmm.
It is being, let's say, resurgent in R&D is for now, because before the mass production and population, you have to have a safe way to approach.
Okay, thank you. Quick question then, maybe hopefully with a short answer regarding when do you think that this is actually on the market for consumers? So I'm a consumer, so I'm interested in this. Is it actually already something that you can buy in a few years?
I believe it will be, especially as the grid is getting decentralized more and more, and it will be I believe it will be a big factor for the micromanagement of the grid. When you
Hmm.
reduce the voltage level, it will be the key factor. The key factor for me, I believe, is to incorporate firstly the system within the grid boundaries and the aspect,
Hmm.
and from the managing side, and then to have a safe and unified software that handles
Hmm.
the aggregator side, and the, let's say, DSO side, the managing of the grid. Then it will be wholesale ready, let's say like that,
Okay.
because the
Yeah.
actually the end user itself, they don't have the direct communications with the DSO, they have it with aggregator. So that's why there are new possibilities of the energy market to found the spot for everyone, if you get the idea what I'm trying to explain.
Yeah, indeed. Okay, thank you very much.
No problem. Any more questions? Okay, then I'll stop sharing the screen.
Sarah, should we continue?
Apologies, I mistakenly shut down the conference.
Thank you very much for your presentation. Any questions? I hope there are no questions, so we are moving on to next presentation by Audron Lemaitre from Laboratory d'Etudes Recherche sur les Matériaux, Université Lorraine, France. The presentation title is Study of the Process of Structural Wood Reuse in a Deconstruction or Reconstruction Operation.
Thank you, Sarah, for the introduction. So, hello everyone. I think everyone can see my presentation. I will switch like this. Okay. So let's start. So I'm Audron Lemech, a doctoral student in the LERMAB laboratory and operation manager for the social landlord Vogelis. I will give you a presentation on reuse and more specifically on the study of the process of reuse of structural wood in the reconstruction operation. So the presentation will be structured around the three principal sections. The initial is the context of the subject. The second is on the reuse process, and we will finally see the conclusion and outlook. So let's start with the first part around the context of the subject. So the study presents three primary focus of my doctoral research, which is entitled Development of Interactive Decision Support Tools for the Reuse and Recycling of Wood and Associated Material from the Demolition of Building, Diagnosis Resources, Usability, and Environmental Quality. It is a CIFRE thesis, which allows me to pursue this research in both a corporate setting and a laboratory environment. I am affiliated with the LABAM laboratory. The laboratory is divided into 4 teams, each with a distinct focus. The first is xylo-sourced materials and molecules, the second wood and waste recovery process, the third high-performance construction and implementation, and the last energy efficiency in building and industry. I am affiliated with the social landlord Vogelis. which is exploring the integration of reuse into its operational approach. The following figures illustrates the scale of the structures, like 50 new homes each year. It's an important landlord in the east of France. In the course of my doctoral research, I am supervised by 3 people: Véronique Thierry, who is a corporate tutor and also in charge of operation at Vogelis; Professor Pierre-Jean Méozoun, my thesis director, who provides me with expertise on the mechanical transformation of food; and the Dr. Caroline Simon, my co-thesis director, who offers insight on life cycle analysis and the wood in the context of environment. The following study concerns the deconstruction of 4 residential buildings dating from the first half of the 20th century. These buildings are located in city in the Vosges department in the east of France. The second figure shows the typology of building in their current states. The wooden elements, in particular, are the beams of the existing floor, showing in figure 3. Vogelis wanted to integrate this wood into future building on the same site and was interested in reusing them. This posed a problem: what procedure should be followed to reuse a batch of structural timber? Now we have seen the context of the project, we can move to the reuse process carried on the deconstruction site on the joist of the existing floors, and how we get from here to here, including the reuse process. The first step prior to the operation and the selection of the project management was to carry out survey on the buildings in order to identify the construction complex that were to be faced. It should be noted that the survey were carried out with full knowledge of the lead and asbestos diagnosis. The survey carried out on the floor of a room made it possible to identify the wooden joists and the construction system of the floor. An initial estimate of the number of joists was made from the plans available and the layout of the joists. In addition, it provided an initial idea of the methodology to be implemented to undertake the selective removal of the joists. This initial information could then be incorporated into the resource diagnosis carried on the site. So the second task in the reuse process is to carry out a resource analysis on all 4 buildings. This diagnosis must make it possible to identify all the materials that make up the buildings, from a simple switch to granite rubble. It must also make it possible to identify the main characteristic of the materials, like the composition, dimension, condition, which will then make it possible to give each material a specific orientation. On the basis of this document, the client and the project management will be able to decide whether or not to reuse material. There are various structures that offer models and or tools for carrying out this type of diagnostic, such as Cyclope, a French startup working in the field of reuse. Once the idea of reusing joists has been put forward, selective removal trials were carried out at building level. These tests were achieved at different locations so that the recovered beams came from different buildings and different locations. Again, the removals carried out in accordance with the asbestos and lead diagnostics. These various removal tests allowed the method of selective removal of beams from existing floor to be refined, but also showed that the local companies working in the reuse sector still need to improve their skills. The selective removal of the beams was carried out in the order shown in the photo opposite. So we have the room, remove of the flooring as much of the leveling compound as possible, removal of skirting board and electrical ducts, and after we carefully remove all the parquet flooring, which will also be reused. So now we are here and we remove the wooden lathing and finally carefully remove the joist, and we are here for finishing. On the theory, it is necessary to move on the practical implementation of the selective removal which took place during the deconstruction phase of the following slide. The company in charge of the construction followed the same methodology as they identified upstream. However, as can be seen on this picture, the joists were removed from below and not from above as originally planned. The joists were therefore removed from the upper floor down to the ground floor. In addition, some joists were left in place uh, uh, before the building were demolished to ensure a minimum diaphragm effects to prevent collapse. There are three essential tasks that took place during the selective removal of the joists and that determine their potential for reuse. The first is the identification of each joist with a unique code to ensure the traceability of the elements. In our cases, the joists were identified with a unique code consisting of the building number, building wing, floor, removal room, and removal order. The parts were all identified with a number prior to the operation, and the order of removal was from the external wall to the internal wall as far as possible. This unique code was then recorded first on a tape, a piece of tape, sorry, due to handling, and then in the second step on a stapled and glued label. The identification and labeling of the elements must be done in the same way as when carrying out the resources diagnosis as far as possible. The second step was to remove the metal elements from the wood. In fact, the step is essential as it facilitates further remanufacturing as well as handling and storage of the wood. To get an idea of the number of metal elements removed, one employee of the deconstruction company was dedicated to this task from the beginning of March to the end of April. And the third task concerns the storage of the parts, which must always be done according to the rules of art. The wood was kept out of the water by being stored under a marquee, and it was also stored on reusable plastic pallets, which protected from rising damp but also allowed air to circulate. If these three tasks are not performed perfectly, reuse cannot be optimal. Once we have the elements, we need to characterize them in detail, particularly from a mechanical and chemical point of view. In our cases, the wood had not undergone any treatment, so the chemical step was ignored. It was therefore necessary to define a simple mechanical characterization method that could be applied to our entire batch of joists. The first was to determine which non-destructive techniques to use for this characterization. The technology had to be non-destructive in order to ensure minimum loss. Two methods were tested. The first is the vibration method using accelerometer, and the second is the ultrasound method using the Silvatest device developed by the Swiss company CBS Live Team. These two instruments make it possible to measure the MOE, or longitudinal modulus of elasticity, one of the essential parameters for wood classification, as we will see later. The various tests were then carried out on the joists that had been removed during the removal test we see before, prior to the dismantling operation. So to compare the result, destructive tests were carried out on the test slab. The result of these various laboratory tests showed that vibration technology was safer to use than ultrasonic technology. The vibration values were closer and lower to the destructive test value than have been the ultrasonic values. A lower MOE value guarantees a significant safety margin in the dimensioning of building. In addition, a comparative study was carried out between a fixed bench and a portable bench for the vibration method. This portable bench was specifically designed for non-destructive testing in the field and was carried out by the metal company Verifier. And this study, the graph of which are presented here, showed that the use of the portable bench gave them the same results as these obtained with the fixed bench, making it possible to affirm that this device could be used directly on the dismantling site. On the technology for characterization has been identified, it is necessary to move on to the classification methodology. First of all, it is important to know that a wood element is not classified on its own. It is classified as a part of a batch. The classification of new wood is based on 3 parameters: bending strength, modulus of longitudinal elasticity, and density. The NFEN 338 standard specify the values that must be met for a batch of wood to be classified in a particular mechanical class. In our cases, the 5 future buildings were designed entirely in C18 wood. For a batch to be classified as C18, it must meet the 2 characteristic values of bending strength and longitudinal modulus of elasticity, which here are 18 Newton per square millimeter and 9 kilonewton per square millimeter. It must also meet the average density value of 380 kilograms per cubic meter. It should be noted that all these values are calculating according to the NFEN 384 plus A2 standard. It is here in the context of reuse that the problem becomes apparent. To classify a batch of wood of a certain origin and species, a bending strength value is required. This value can only be obtained by carrying out destructive tests, but there is a way around this problem. For the mechanical characterization of a batch of joists, we use the NFEN 14081-2 plus A2, sorry for this, adapting it to the constraint of reuse. More specifically, we will use the indicator property method. By applying the method described in the standard, where our indicator property is represented by the value of the longitudinal modulus of elasticity obtained by the vibration method, we classify our batch of joists resulting from the selective removal test. At a given moment, we classify our batch of joists is no longer meets the minimum values for the batch to be of the desired mechanical class, in our cases C18. Therefore, the value of the indicator property related to the last joist integrated into the batch that is still valid is the limit that the joist still present on the site must respect in order to be the desired mechanical class. In our cases, for a joist to be a class C18, it must respect the value of 7,914 Newton per square millimeter obtained from the vibration test. So let's start with the means graphically to make it clear. So we have a batch of 11 joists in the batch. This batch validates the bending strength, the density, and the modulus of elasticity. And so the batch is classified as a C18. We have just introduced an additional joist into the batch, numbered joist 15. This invalidates the flexible strength value required for the batch to remain C18, despite validating the density and the modulus of elasticity. We then know that our limit of the one corresponding to joist number 11 is of number 11. Sorry. After this characterization, still according to the standard, we verify our characterization methodology. In our cases, the characterization is valid according to the criteria given in the standard. Once the methodology had been identified and validated, both at the standardization level and by the design office, the carpenter, and the technical inspector, it has implemented on the site. A floor was creating using pallets and parquet stripes from the site. This installation provides better measuring and working condition. The portable bench was brought back to the site and set up. It should be noted that weights were placed on each of the feet to ensure that they did not move and to limit parasitic vibration as much as possible during the measurements. The specific equipment for the measurement then mainly consists of a scale with a capacity of 100 kilograms, an accelerometer of a being device, it's like the vibration, which allows the measure, a wooden hammer to vibrate the beams, a meter to measure the dimension of the beams, and a moisture meter to measure the humidity of the beams. So the method used therefore consists of limiting from the outset with joists that don't not meet the minimum requirements, like too small dimension, cross-section and length, the defect on cross-section, the defect in geometry like warping, curling, the defect due to humidity or the presence of insects. These joists are then kept in the buffer storage area, as mentioned in the figure 16. With the joists that don't not validate the limit value of the modulus of elasticity, the joists are then kept on the buffer storage to be reused in other cases, not in situ place. Once the initial check has been carried out, the validated joist is weighed and then placed on the test bench. Its dimensions are then measured with a meter and moisture content is measured with a moisture meter. The accelerometer is then installed using a screw, which is placed in the middle of the section at one end of the joist. All the initial data measured is then entered into the software dedicated to the vibration method and the acquisition is started. The joist is then put in vibration using the wooden hammer and the software gives the value of the modulus of elasticity. If the value not comply with the previously determined limits, the wood is preserved in buffer storage area to be sent to one of the association working for reuse, and so they can be reused ex situ. If the value is met, the wood is stored in the trailer intended for the carpenter and the independent laboratory, like in figure 17. In fact, 40 joists taken at random during the test are sent to an independent laboratory which carry out a destructive test again to ensure that they are all C18 class into to validating the castigation method. The rest of joists are sent to the carpenter for storage prior to the reworking phase. So once the joist has been characterized, we can move on to their remanufacturing. This phase is carried out directly in the carpentry workshop, which is located just a few kilometers from the site, free in precision. At present, the joists are not been yet reworked. However, the various machining operations have already been identified. We create a reference surface by planing. After we screwing the timber section to the reference surface, and we size the elements by shaving. These operations are necessary for the correct implementation of the joist in the future wood concrete floor. 2 points must also be taken into account during machining. The possible metal elements that will remain despite their removal during the selective removal phase, and the funnel of the joist, which is constrained by the future implementation in wood concrete floor. The width is limited by the wood concrete as a connector used. Also, this operation have been carried out, the joist can be transported to the site in the same condition as the new joist, and installation is carried out in the same way as for new elements. Now that we have seen the process of reusing the existing floor joist and the motion site, we can move on to the conclusion and perspective of the study. The picture shows the future housing project that will take place on the site and which integrates the beams. So in conclusion, we can say that the process of reuse of wooden construction elements can be divided into 5 main phases. Carrying out a survey that must allow an initial identification of resource available. The carrying out of resource diagnosis, which must give the first characteristic of the elements and the possible orientation to be given to them. The selective extraction phase, if reuse is desired, attention must be paid to the removal element that must be removed to facilitate future reworking, to the identification of each element to ensure traceability throughout the operation, and to the storage of the elements to ensure their future use. The characterization phase divides into a chemical characterization phase if necessary and a mandatory mechanical characterization phase. So the various skaters on site must be involved in this phase as far in advance of the operation as possible. Oh, sorry. Okay, I'm here. Sorry for that. And the reworking phase, during which attention must be paid to the specification related to the future use. The study highlights some perspective on the reuse of timber building components. The use of resource diagnosis should be mandatory to promote reuse and encourage project managers to practice reuse in their work. Selective demolition should be included in training at both the practical level, like deconstruction profession or carpenter, and the technical level, like architect, engineer. This will strengthen the skill of those involved in the construction and encourage the development of such practice. And the mechanical characterization of elements should be integrated at the normative level and monitored at the legislative level in order to promote the development of such practice. The reprocessing of reused wood should be integrated with manufacturers and the offer around this action should be developed. And finally, this study also highlights more general perspective on the reuse of wood building components. In terms of life cycle analysis, the reuse process through the different stages that make it up must be integrated into the LCA modeling in order to have a precise idea of the carbon cost of the reuse. And this approach also makes it possible to identify the sensitive points for reuse, but also to produce environmental and health declaration fish specific to the reuse elements. Although this practice is supported by the state through the latest environmental regulation, RE 2020, it needs to be strengthened, in particular using the LCA tools. And in economic terms, the reuse process must be integrating from the start of a construction project in order to identify and anticipate the additional costs associated with such a practice. It is through increased anticipation that the additional costs can be managed in most cases. And the sustainable integration of the practice into the construction sector will also make it possible to reduce the cost of reuse, as construction stakeholders will have a better understanding of the practice and will have gained experiences that will enable them to be better control their costs. So thank you for your attention to this presentation, and I hope that it has met your expectation as possible. Any question?
Thank you very much for your presentation. Any questions? I hope there are no questions. We'll move on to the next presentation by George S. and Samanant, Imperial College London, UK. The presentation title is SRF Pyrolysis: Recovery Potential and its Role in the Circular Economy.
Hello?
Yeah, hello?
You hearing me, right?
Yeah.
Um, just to recheck, am I the one who next in the slot? Because I check in the schedule. It should
Yes,
be
yes, but Jin Song is not attending the conference.
okay, so it's me now, right?
Ah, yes.
Okay. So please let me know that everyone see my slide.
Yes.
Okay, so my name is Jarudet Asingsmanan. I'm just recently graduated from Imperial College London. Right now I'm go back, I'm staying in my country in Thailand. So my research topic is in the idea of waste recovery. So my research analyzes the process of pyrolysis when applied to waste material and analyze all the data in the context of the circular economy. Let's talk a bit about the challenge that our world are facing right now. The first challenge is about, as we know, our world have increase in urbanization, growing population. So we tend to extract more resource from the planet. If this number is keep increasing, in 30 years, the resource that people in the world use will be double from right now. When we use more resource, we produce more waste. So right now, there are 2 billion tons of waste are being generated per year, and the trend is increasing drastically, and it will reach over 3 billion tons within 20 years. And all the resource use and the waste that we produce, we release more and more carbon dioxide. From the graph on the right, we can see that from the industrial revolution, the carbon dioxide emission is increased significantly, and that is not what we want. So the idea in our world, so we produce the sustainable development goal, waste hierarchy, the Paris Agreement to suppress the amount of greenhouse gas emission to control the increasing temperature rate of the world, and carbon credit to recently. All of this revolve in the idea of decoupling idea. The decoupling idea is the way to achieve the sustainable development with low carbon. As we know, the economic need to be growing. We have more population. We want better life. So we tend to use more resource, spend more resource from the world to generate everything. But for this idea, we need to be more efficient to use the resource, to use less resource. And as well, we need to produce less environmental impact and all impact to the environment. So for this idea to happen, it requires innovation and policy to work together. In the area of my focus from my thesis, from my research, I focus on the idea of circular economy, where the material that should become wet and end up in landfill or discarded, they can be recovered and retain their value within the value chain loop as long as it can be. And the pyrolysis is one of the process that I'm interested. And the pyrolysis in here is act as a final unit to prevent any leaking of waste to the environment, and then it convert and recover all the waste into secondary resource to reduce the primary resource use from the planet. And then when I use the pyrolysis, the material that I study with the pyrolysis basically is municipal solid waste. So the waste that we tend to produce every day, and the the major component of this waste mostly is contain organic waste and food waste, almost half the waste, and plastic and paper. They contain vary around 20 or 30%, and all of this is varied according to the type of the demographic and country. Now let's have a look on the figure on the right. The way of these waste are being disposed is not sustainable. Most of them are treated by open dumping or uncontrolled landfill. So the idea we want to go, we want to move it from open dumping and landfill toward incineration, composting, or recycling. And in here, before using the waste into any application, as the waste, the municipal solid waste is very heterogeneity. So the there are some process, some mechanical treatment process required to prepare to pre-sort it before using it as an energy. So in here, the MSW are passed into the process of shredding, screening, and mixing to increase the homogeneity, and then it will be ready to be used in the energy application. So normally SIF and RDF, this material, they tend to use in the incineration, but in my project I want to study it with pyrolysis. Okay, sorry. So just briefly talking about the pyrolysis process. It is the process that heating the material to over 400 to 600 degree temperature without oxygen. So it is a non-oxidizing chemical reaction. The series of chemical reaction happen and it crack down the long chain complex chemical such as the biomass or plastic into their basic monomer, forming three main products, including gas, oil, and solid char. As I said, when the adsorbed from the municipal solid waste, most of the time they are end up in landfill and they can produce leachate and methane, and thus affect environment badly. So once these MSW are prepared into SIF, it's more suitable to use in the energy application. In this case, is for incineration process, and when used in the incineration, all these material are extract in term of energy. But the plastic and the paper over here, they are also contain the chemical value. So in here, waste pyrolysis tend to sit slightly higher in compared to direct combustion for energy recovery in the waste hierarchy, because it shows the potential that it can recover some form of pure chemical to be used as raw material from this process. Sometimes it can move up to the level of recycling, the chemical recycling level of the material. This is the whole research scheme from my project. We can see that from the resource extraction, it's come to material production to use and it's become to waste. And normally this waste is go to landfill and all the value of the material just disappear and turn to the environmental burden. In here, introducing the use of SRF also encouraging the recycling process because during the mechanical pretreatment process is including sorting and separation. So the process can extract some glass, metal, and aluminum to be further recycled, and the leftover stream of the rich energy materials such as plastic and paper that are very low quality, they are beyond recycling or hard to recycling. They tend to be SIF and feed to the pyrolysis, where they get pyrolyzed and cracked down into gas and oil, and then they can return to be used to serve the material production or the society use in terms of energy or raw chemical. And the solid residue that left from the pyrolysis is contain a lot of carbon, and that carbon can consider as a carbon capture and storage as well. So the whole method, or the list of experiments that I run during my research, they can be grouped into three group: material characterization, so study all the property or the composition of the SIF, and then the parameter and the result help to decide the experiment, the pyrolysis experiment. After running the experiment, the pyrolysis product, including oil, gas, and pyrolysis char, they are collected, keep it, and then analyzed to identify their potential application. So this diagram showing how the test of each test interconnect to each other, and the result will go along with this diagram, which will be discussed later. And now I'm showing some key results that we identified during the research. The first one is the characterization, the manual sorting to understand the individual component of the SIF. So around 65% of the SIF material is consists of plastic and paper, and the rest is com- com- consists of the composite material, rubber and wood. The interesting here to see is that no matter how well the mechanical treatment process is, it will be some leftover material in the other group. There are some kind of very fine particle that get into the SIF sample, representing the impurity in the process. And now for the SIF sample, the elemental analysis including CHNS, oxygen and chloride, and inorganic element. Half of the SIF consists of carbon, but the material also contains very high amount of oxygen, which mainly influence from the presence of the biomass. And this high number of oxygen is the factor that reduce the energy content of SIF to be lower than typical fossil fuel or typical commercial fuel that the market currently use. And seeing at the inorganic element, aluminum and calcium, they are the main component of the SIF. In here, the thermal analyzer showing the thermal behavior, the weight loss of the sample over the increasing temperature. This figure signal that no matter how many types of the material contained in the SIF sample, but based on their thermal behavior, they can be grouped just into three groups. The first one is the temperature decomposition range from 200 to 400. They are in the biomass range. They are mainly the decomposition of lignin, cellulose, and hemicellulose. And the second range of decomposition temperature from 400 to 600. These are the weight loss region of the plastic and polymer. And at the temperature over 700, the weight loss over there are mainly account for the calcium carbonate decomposition. So based on this thermal behavior, the material in SRF can separate just into three groups. And based on the single material, the decomposition profile of each single material, textile and composite material, they have the decomposition range exists in these two range, which means that they are the combination of plastic and polymer in one material. And now all the analysis from the SIF, the carbon content, the volatile matter, and the data from thermal analyzer, it helps to set the parameter to run the process, to run the pyrolysis process. In here, in my research, I have two types of pyrolysis reactor. The first one is the normal thermal pyrolysis. The second one is the microwave pyrolysis. And all the data are run based on experimental design with the main purpose to maximize the oil yield, because the oil is the main product that tend to carry most value from it. And here is the result from the oil analysis from the SIF pyrolysis. So around the majority component on this oil is contain benzene, toluene, LT-benzene, and xylene and styrene. So this chemical can be extracted and purified and resell into the market, and they are valuable chemical. So recovering this from pyrolysis process consider as the chemical recovery and return this to be used as a raw material, embracing the concept of the circular economy. The next one, the gas content. The gas is a non-condensable volatile product that left after the pyrolysis process. The gas was collected in the Tesla bag and tested to find the composition of the gas. And we can see that hydrocarbon gas C1 to C4 is present in the proportion of gas. And from this data, we can use it to theoretically calculate the heating value of the pyrolysis gas, and it's turned out to be very high at around 40 megajoule per kilogram, which is in many cases this amount of energy can be burned. This gas can be burned in turbine or gas engine to generate heat and resupply to sustain the process, which reducing the requirement of external energy to sustain the process. Thus, reduced a lot of resource requirement to make the whole process running sufficiently. And in here, the last product that left after the pyrolysis. So after the material, the SIF material being pyrolyzed, most of volatile matter are released and condensed into oil or left in form of gas product. But the solid residue that left in the reactor after the process is called pyrolysis char. And this char will also test and also were tested in the similar way and compare with SRF. And the result show that the pyrolysis char contain around just 40% of the carbon, but the non-CHNS element is very high, like 40 to 50, almost 60%. This signal that the pyrolysis char contain a lot of ash content, something inorganic. It means all the inorganic material that presents in the SRF after pyrolysis, they all stay and remain in the char and even more concentrated in terms of proportion of it. So this ash content introduce a challenge in terms of recovering or reuse of the char sample, because most of the inorganic element in this ash content are sometimes and is unwanted content. it's very difficult to find the practical application for the pyrolysis char at this moment. But when considering the carbon content that stay in the char, this carbon that stay in the char represent the potential to be a carbon sink. For example, during the start, the SIF has 51.86% of carbon. If this SIF were combust or feed to the incineration to produce the heat and energy, all this carbon, like 98 or 99% of this carbon, they all combust and turn into carbon dioxide. But in pyrolysis, some carbon in form of the volatile matter, they are converted into oil and gas. But this carbon at around 40% in the chart, as it's right here in the chart, in the middle column, the chart after the pyrolysis, they are around 20 to 30% of the yield of the chart is around 20 to 30% of the input SIF. And in that chart, it also contain the carbon around 30 to 40%, and it's represent around 9.87. And this amount of carbon that stay in the solid form in the chart represent around 30% carbon sink from the total carbon content originally in SIF. The concept of the carbon sink and carbon efficient can be explained by this figure. Instead of the waste or the biomass, all the carbon there burn and transform into carbon dioxide. The waste then feed into pyrolysis plant, and some portion of the carbon compound turn to gas and oil, and this can be used as an energy or chemical recovery. But as I say, around 30% of carbon from the original carbon from SIF, they are transformed into the solid form, solid char, the form of very stable carbon, and this carbon can be used as a carbon sink, and it can be used in the solid applications such as used for the mixing with the concrete, used in the ground application, or even used in the mixing with the soil. And in here is the systematic diagram of all the pathway and chemical reaction that occur during the pyrolysis process. And all this data are obtained from the test of the SIF sample and product after the pyrolysis. And then with some addition of the literature review, I can identify almost all chemical reaction that happen during the pyrolysis, how the single input material transform into the final form of the pyrolysis product. And from all of this, in terms of the yield, it can be represented in the Sankey diagram to show the material flow and representing the circular economy as well. So the point that can create the loop representing the opportunity for circular economy. Right now, only benzene, toluene, anti-benzene, xylene, and styrene from wax product and some inorganic metal from pyrolysis char. In here are copper and zinc. They can be recovered and returned into the societal use and then become waste again. So this represents the opportunity for circular economy. But clearly we can see that the circular loop still very thin, which means that there are a lot of room for improvement to increase the recovery potential of this waste within the pyrolysis scheme. Thus, with further work and more development in here, it can be increase the waste pyrolysis process, increase its contribution into the circular economy even more. So The future direction, the future research that should be done is to focus more on recovery or extract the inorganic metal or inorganic element from the carbon from solid char. In that way, we can potentially recover the metal, more metal from the pyrolysis char, as well as what left in the char can be even more pure carbon, and it can be used for carbon application or even used as a activated carbon production. And the next one is about the pyrolysis process. As the SRF or MSW, the municipal solid waste, they are mixing between waste plastic and paper waste. If the reactor can run in two steps, one step to decompose the biomass of and paper first, and the next step to decompose plastic. So it's gonna be more convenient and easier to separate the liquid product, and thus the recovered chemical can be even more pure. And with all this research, it can enable the pyrolysis process to be the answer, the key solution to make the efficient and effective enhanced circular economy system. So thank you so much for having me here today. And this is the picture from the lab a little bit. And if anyone have any question, please feel free to ask.
Thank you very much for your presentation. Any questions?
Yes, if I may. Very nice presentation. I'm curious about the environmental impact. So you show that you have a yield of 70%, which I think is nice, especially considering that you're doing it on waste. But then you get a product, which is then toluene or something similar, and that will have to go onto the market. So it will be in competition with petrochemical materials. Can you say something about the comparison between the one and the other? Of course, we need legislation in order to help these materials to be used effectively, but is there anything you can say about the economic viability and also the environmental impact of this approach?
Okay. So let me address first about the economic viability. So this factor is the one area of the challenging right now, because the product from the pyrolysis have those standards to cover right now. So for example, people who run the pyrolysis, who produce this chemical, they need to identify their customer by themselves, and they have to have their own agreement about the specification of the product that they trade. But now moving to the environmental impact, because of the process to produce this material, they are mostly come from the hydrocarbon or petrochemical industry, like benzene, toluene, refinery. This industry right now, they contribute a lot, hugely contribute into the greenhouse gas emission and the impact upon the resource extraction. And right now, as the global warming and everything in the world, the availability of the resource tend to decrease. So at least the waste pyrolysis right now, it help to fill the gap of the resource requirement in terms of BTEX. And when we compare the life cycle assessment of this product, the environmental impact and the greenhouse gas emission from the waste pyrolysis, they are tend to be lower compared to the traditional way of the production of this chemical. Because one advantage is like the process receive the waste, so it help solving the waste problem. So the pyrolysis gain the environmental advantage from solving that waste over another process. But once it's produced the chemical and that chemical return to use, yes, it still contribute to some impact, but overall when everything trade off, the process show a promising potential to be, I would say, environmentally efficient, not environmentally friendly. Yes.
Mhm.
Hope that clear to you. Yeah.
Yes, yes, thank you. And of course, if we move more and more towards green energy, then I'm sure the amount of burdens you have to do in order to get these materials from waste will decrease further.
Yeah, yeah.
Thank you.
Any more questions?
Maybe I can ask another one on the char, actually. Can you do hydrometallurgy or metallurgy in a different way on the char to recover some of any residual metals or something else?
Um, the the first thing, the most convenient way and the very primary thing to do is like some metal they present in the chart in form of metallic piece.
Hmm.
So the magnetic separator or eddy current separator, sometimes they can extract that metal directly, like physically from the char. But
Hmm.
some metal that are very small, at the end, they would require some acid demineralization, like hydrometallurgical, to
Hmm.
remove that metal from the char anyway. And this technique mostly they are right now at the moment they are applied to the incineration bottom ash or electronic waste, and it's worked well with that waste. But right now is it should be worked with the pyrolysis char as well, and hopefully it will be the one topic that I will continue my research in the future. Yeah.
Hmm. And would you want to do the metallurgy before actually doing the pyrolysis, or is afterwards still okay? I think for the metals it does not matter too much, but
I think afterward would be better, because sometimes the acid might disturb the plastic or the like the volatile matter or the organic material in
Mhm.
the starting waste. So it would be better to extract that volatile material in the purer form using just the heat from pyrolysis, and whatever left in the solid form right now mostly they just contain carbon or some a little bit of volatile matter and ash and the inorganic metal. So that way would be more locally ordered rather than do it before. Yeah.
Okay, thank you.
Thanks.
Thank you. Any more questions? I hope there are no questions. So thank you very much for the Q&A part. We are moving on to next presentation by Stephen S. Harkema from TNO et al. Center, Netherlands. The presentation title is A Step Closer to Sustainability with In-Mold Electronics.
Yes, thank you very much. Just a quick test to see if I shift my slides now. Yeah. Thank
Yes.
you. Good afternoon, everyone. My name is Stefan Harkema, very Dutch name. I want to present the results from our work on in-mold electronics and actually trying to make it a sustainable, if not circular, type of electronics. So I want to thank the organizers for giving me the opportunity to present you this work. So we are located in the Netherlands. Whole Center is an independent non-for-profit research and development institute. And we have two parent organizations, which is TNO from the Netherlands, with about 4,400 people working, and IMEC from Belgium, well-known semiconductor-based institute with about 4,300 people. So we have about 260 of our own employees, all located on these premises on the high-tech campus in Eindhoven. So the high-tech campus is now a shared site. It used to be part of Philips Research Campus, and then around 2005 it got shared. Now about 200 companies are located there with over 12,000 researchers. The whole center has its own research and development labs, as well as a pilot for manufacturing for printed and flexible electronics. And in addition, we also have facility sharing. So semiconductor laboratories, but also materials analysis, previously facilitated by Philips Research. So what do? We are developing next generation of PCBs, printed circuitry board, and basing it on now printed electronics instead, and we develop enabling technologies to do so. So we can do this on flexible substrates, stretchable substrates, and also on a polycarbonate, which is a thermoplastic that you can give a new shape, 2.5 or 3D. So we believe it's easier for final product integration. Also, we believe you have more design freedom in order to make this into an appealing product for various domains. And it's better fit for function, for instance, in healthcare, where a PCB would not often fit the application, but if you have something which is conformable, would. I will talk about the environmental impact and how we could further improve that. And it is also well known that the volume scalability of printed electronics is quite good. You can make this in relatively small series, but also increase this to mass manufacturing. So I dive a little bit into what is printed electronics. What we do is we make use of metal inks rather than pure metals. We apply these via printing techniques, for instance, screen printing onto a surface. That could be thermoplastic polyurethane, polycarbonate, PET, to create circuitry. This circuitry can be complex. Here an example of a multi-layer PCB-like circuitry, and that is then combined with heterogeneous SMT components in order to make PCB replacements. So here featuring a sensor, microcontroller, and also passive components. We typically do this for various type of applications in various markets. So here, example applications. So we are active in medical, creating medical wearables in order to measure various biosigns. Also, we have a combination with photonics arrays and also ultrasound, and we are currently diving into smart wound care. We can also use these kind of technologies in order to make large area sensor arrays that you could embed, for instance, in shoe soles as an example, but also in mattresses in hospital in order to monitor patients on the beds during long period, thereby preventing the occurrence of certain wounds that might occur. Also, printed electronics can be integrated into smart clothing. We have a spin-off in order to bring this further into the market. And you can process either directly on a textile, but typically it's processed on a TPU and then laminated onto a textile. This can be done for pilots, for instance, but can also be done for sports in order to monitor the health and well-being of athletes. The fifth one, I'm skipping the fourth because I will go dive more into that. The fifth one is display and lighting integrated into, for instance, glass sheets for automotive. Also here you want something which is transparent as a circuitry or near invisible. And of course, if you stand a little bit further away, it's hard to really see very fine lines. It's what they're already relying on for heating of car windows, but also you can make this a circuitry and embed very small LEDs. that do require a different way of applying these, for instance, via laser-induced forward transferring. So the fourth one is structural electronics, also known as in-mold electronics. We are at the moment working on making this much more sustainable. But another example of structural electronics is really 3D printed electronics, building up the electronics layer by layer and embedding the electronics there. So this can be done for automotive, consumer, and industrial applications, but typically automotive is driving this. So evidence appears to be piling up that hybrid and printed electronics has a lower environmental impact than typical printed circuitry board applications. So here an example for a lighting device, a luminaire that is made either by PCB. On the far right side, you see a picture, a product by Signify. So this is the base plate with the LEDs that is further incorporated into a luminaire. And we have made a hybrid and printed electronics version of that, and those were compared in a life cycle analysis. And if using still petrochemical materials and mined silver, then we get a reduction of about 65% in carbon emissions. And if you look into the other impact factors, which could be for ecotoxicity or other aspects, then you see that there's quite a big reduction in some of them, not always all of them, because it really depends on where the materials are coming from and what may be used inside of the plastics. But this is a first good step. And what is not shown here is actually that in this project, Ecotron, there are further steps using bio-based or recycled materials and copper instead of silver, which also provides significant further reduction. So still, we are making electronic waste, and we are making a lot of that as a humankind. So the amount of waste is building up, 62 millions of tons in 2022, which is a great increase since 2010. So how can we make our electronics more sustainable, if not circular? Here, a picture from Ghana, where our electronics are being burned in order to recuperate the copper. So we have to prevent that this occurs under these conditions, which are absolutely not healthy. So for automotive, the World Economic Forum Circular Cars Initiative has looked at the possibilities in order to reach a high level of circularity. So 4 strategies were defined. The top one being energy decarbonization, which suggests that we first move to low carbon production, also using low carbon materials and eventually a circular material stock. And of course, make use of energy grid integration. For the second strategy, material circularity, there we have to think about reducing production scrap, but also end-of-life management, for instance. The third one being lifetime optimization. This has the highest priority. If you can extend the product lifetime, you will avoid having to waste emissions on a new product. So that has a priority. But you can also think about different business models regarding leasing and subscription, but also having circularity hubs. But also this strategy includes reuse and remanufacturing at scale. Modular design also very interesting to include. The last one, utilization improvement, focuses more on different concepts. For autos, for cars, it's actually sharing of cars rather than each person having his or her own car. So more a mobility on demand approach. So we also know that there has been a powerful instrument in the 10 Rs. It used to be 3 Rs, but now it's been extended to 10 Rs, where the lower the number, the better it is for the circular economy. For instance, the R0 being refuse a certain hazardous material, like has been done with lead-containing gasoline, that it has been removed from there, and it requires us to rethink certain concepts. Reduce, the R2, also important in order to achieve energy decarbonization. It's actually low-hanging fruits. If you make something thinner, more lightweight, you save a lot of CO2 over the lifetime of, for instance, a car. Then once a product exists, then we are in the R3 to R5, is extend the lifetime as much as possible. And once end of life has been reached, we move towards the R6 to R8 and even R9, you have to think first about concepts like remanufacturing or repurpose, and if that doesn't work, recycle to recuperate the materials. And if that is no longer possible, then you incinerate for recovery of heat. The R10, not mentioned here, is then something which is in the EU not allowed, which is landfilling. So at Whole Center, we want to refuse the PCB actually, and believe that we can incorporate as much of the PCB's functionalities within a product that is based on hybrid and printed electronics, so the R0. We want to make use of the big benefits, which is additive manufacturing, which is typically done on something petrochemical, but we see that it's being changed to bio-based surfaces and recycled materials instead. And ultimately, we would like to have a material which is fully renewable. We make use already of efficient processing, but could do even better, using a little amount of material as low as possible. For instance, we, with additive manufacture, only apply the metal there where it is needed, so we don't have to use chemical etching in order to remove a certain metal. We are looking into design for recycling, which is an approach that will dismantle the device at end of life or maybe during production if something has failed. And this will also help us to target repairability. So I will go into that in just a moment. And we believe this is something that the entire ecosystem has to do. This is not something that one or two companies can do. You have to involve the entire ecosystem and even involve the end of life companies, the recyclers and the dismantlers. So I'll give you a few examples of how we apply these circular strategies. Here we have the pathway for lifetime optimization, making use of a modular design. So health patches can be recycled. They could also hypothetically be bio-based and biodegradable, I should say. But if you have SMD components on that health patch, you cannot, that is not something which is biodegradable. You cannot put it onto a compost heap. You could put the functionalities on a ever smaller PCB and then have that something as a unit that can be reused. So you're separating an element which has a lifetime of a few weeks and something which can go on much longer, which is then the PCB which can have a lifetime of several decades. So you don't have to throw away the PCB along with the health patch. Another one is here an example where you fully integrate the PCB functionalities within the printed electronics. This is an example borrowed from Tactotech, where here they have a base plate consisting of polycarbonate. They have printed the circuitry, which you can see in gray. Then on top, they apply the SMD components, which are, for instance, LEDs, but also they have integrated a chip, a system in package, as they called it. This chip replaces the PCB driver, the external driver, completely. So you only have a cable that goes into a computer, a driving chip for the rest of the functionalities and the further integration into the dashboard. So that is then thermoformed and injection molded in order to complete their final seamless part. So that is one example. PCBs have a very high environmental impact, and if you replace that completely, you're able to omit it and embed the functionalities using such a chip. You could reduce the total environmental impact of your product, and then still you have to make sure that that is on the positive side. But they have done this calculation and say it is on the positive side, so really a reduction. A second one is a transition to lower impact materials, the low-hanging fruits, the pathway of energy decarbonization. We have several examples where we are replacing silver with copper or replacing petrochemical materials with something recycled or even bio-based. So here examples of recycled polycarbonate for overmolding and recycled PET we've used in several examples. And also the printed copper is a very nice example because copper is much, much better for the environmental impact reduction than silver. Then, of course, pathway for material circularity. We have a part which is mostly plastic, let's say 99% plastic, which is a little bit of metal. That doesn't recycle well, and we decided to focus on the dismantling of such parts. So in number 1, we have the encapsulated part. We want to remove the encapsulant in order to be able to directly access the printed metal as well as the components, so that we can separate these from the substrate and have efficient recycling of all elements. And this design for recycling we've tested in in-mold electronics. So on the left side, we see a white foil, graphic black with graphic white printed and cured. On top, we have in gray the printed circuitry, and then very small 132 components, LEDs. And then we apply an additional layer, which is here very visible as a blue layer. And on top of that, we apply with overmolding polycarbonate, a few millimeters. So the components and the circuitry is fully embedded within the polycarbonate. As this dismantling layer, we can use non-adhesives as well as weak adhesives and reversible adhesives. We have a program where we test all kinds of variations, all leading to the industrial application of this approach in order to dismantle such electronics. So we collaborate with Tactotech, a Finnish company, quite dominant in the field of in-mold electronics. And we have applied our approach in their device, which you can see here. And I will now start a movie. I hope you can see it, where I dismantle within about 16 seconds such a device after first thermal treatment. So this was made with reversible adhesives. So I'm a little bit clumsy. It takes me 16 seconds, but I'm sure that a machine could do this within a second. Then if we are changing the design, we're adding a layer, then of course you have to check the reliability. We should not shorten the lifespan of such a product. Actually, we should have the same or longer. Longer is already quite challenging, but at least not compromise the reliability. So we do automotive reliability tests. Here are the results from a humidity test, which is 1,000 hours at 85. And after this result, also within Unicorn with Tactotech, we are looking into the different additional reliability checks, such as thermal shock, thermal cycling, high temperature shelf testing, etc. We also look at end of life recycling, different way than the previous speaker. Here kind of a life cycle for plastics. Optimal would be reuse of plastics. The next best would be, if you recycle, that you have open loop recycling. That could be thermomechanical, but it could also be the way that we've done it, which we call physical recycling via dissolution, which works well for polycarbonate, for instance. And it avoids that you have to remake the polymer starting from the feedstock or the monomers. So it is a minimal additional step towards getting the plastics, which you then can use in the products. So we have been able to recycle the polycarbonate from such an in-mold electronics device, which you see in the top left. And the polymer that we recuperated was we had about 80% of that material left. There are industrial examples where they have a yield of 90%. And we then compared the spectrum of the polymer with the library, and we found that it is almost a perfect match. So we believe it is pure polycarbonate. This approach has the benefit that you are removing any colorants, any kind of other additives like softeners, which helps you to reformulate and recompound a plastic that you could immediately apply in production of such in-mold electronics products. So this end of life is targeting first also the polycarbonate, but the money is actually in the silver. So we've done recycling on the intact devices, but also on the dismantled devices. And what we see is that the dismantling helps us to also target the silver dedicated fashion. And Univac, University in Italy, has helped us with that approach in the Treasure project. They've been able to recuperate, I think about, high up in the 80s, I think about 90%. And then of course there's this purity. So I think the level was about 83% to 85% of recuperated silver ultimately through this process, which was a quite nice result. We have also spoken with recyclers. This kind of e-waste is a problem, as far as I was told, having a too high caloric value, so too much plastic in order to make recycling focused on the silver economically viable. So on one hand, you have the PCB recycling, which is established, focused on 20 to 30% copper in a PCB. And then we have such in-mold electronics with about 1% of silver in there. It's not a lot, might even be less. And we hope that with this approach, we are improving the recyclability rates and also the economic viability. We have also looked into the pathway of lifetime optimization, really to come to make use actually of the dismantling of such a product so that we could target manufacturing fails. Perhaps also something which occurs during the use phase, but that is a tricky one. So here you see a picture of a repaired in-mold electronics device, a lighting device, and we are studying repairing of such devices in the circuits project. So here on the left side, we have an example of a manufacturing fail. You see that some LEDs light up, but certain strings do not light up. Through our approach, we were able to separate the injected encapsulant from the substrate. You see then that the substrate is still lighting up in a similar fashion. We could then measure where we have the fails and repair that with our metal inks. And then we overmolded a second time and got then the repaired product. You can see that the design has changed a bit. You see that the blue layer now contains circles and a recycling emblem that is incorporated into design, which is already there in the original product, but is emphasized once you dismantle it first time. So we hope to submit the manuscript quite soon. So with that, I hope to show that we are now a step closer towards sustainability. We've tried to apply as many circular strategies to this kind of technology, which we consider to be very challenging, and because it's an encapsulated type of hybrid and printed electronics. Nevertheless, there are many possibilities in order to improve this, making it perhaps much more sustainable than PCBs. I want to credit various projects, EU projects that we are a part of, and I would like to thank you for your attention. If there are any questions, please let me know.
Hi, hello.
Hello.
Thank you very
Thanks
much for
for
your presentation. Any questions?
hello. Can you hear
Hello.
me?
Yes.
Yeah, it's thanks for the presentation. It was very interesting,
Thank you.
and it's like as we just discussed before, I'm very interested in the hydrometallurgy process about like recover the part from the P and HE, if I understand correctly. So I would like to hear more. Or could you explain me more about this process or something like that? Is the area that
Hydrometallurgy.
like yeah
So this is actually a process that is developed by Univac, University of L'Aquila. And
yeah
what they've done is used leaching methods in order to remove metals from the surface. And actually they've used Thurea, if I'm not mistaken, in order to leach the silver. So they have their own patented approaches. So they're trying to improve the sustainability of this chemical removal of metals, the dissolution of metals. But they have used also this Thurea acid combination in order to remove silver.
okay. And from the polycarbonate that passed through this process, it can be reusable, right?
Good question. We saw that the polycarbonate does sustain a little bit of damage. So
Yep.
you were right when saying that you are affecting the plastics by using an acid on them. It was a little damage. I cannot say that the polycarbonate immediately turned brittle and broke apart. But when we did the analysis of the molecular weight, that's as far as we went, we did see that there was an impact of how long the polycarbonate was exposed to acid.
Okay. Yeah. Okay. Yeah. Thank you very much.
You're welcome. So I don't know, this is the Tirea approach. Of course, they have different approaches in order to dissolve the silver and also copper. So I cannot say that that is the case for all of the approaches that they have, but for the Tirea approach, it was the case that there was a little bit of damage. But it was not a lot, and it might not hamper with the reuse of the polycarbonate afterwards. But we are especially targeting the encapsulant, which is about 90% of all of the plastics that we have used. So we have room to maneuver and to make different choices with the substrate. Since we have now a substrate with all of the silver, all of the metals, we are now able to recuperate that polycarbonate, 90%, and also target the substrate separately. And that is not possible if you do not dismantle. Any
And
other questions?
I
Oh,
think
sorry.
it's gonna be just one more quick question. So when you say about the dismantling process, so right now normally it's gonna be dismantling by human, right? It's not by
Mhm.
machine or yeah. Okay.
At the moment, indeed, because this is not existing yet for the current industry. I think there are manual steps when it comes to removing batteries, when it comes to removing gases. That's also probably already automated. But in-mold electronics and other printed electronics is not really an existing e-waste stream. I mean, the recyclers we've spoken to don't know this type of waste yet, so there is no treatment specifically for this. Should you treat it differently than e-waste, or should you focus on it separately? And I think the latter would be best. But at the moment, there is no way to recognize printed electronics. And the application is not, so we will have to make use of the digital product passport in order to identify this kind of product. And then you have to take it out of the regular way of working, because if you recycle it along with the PCBs, you will pollute the PCB waste stream simply because this has a much lower amount of metal. And if you treat it as a plastic, a polluted plastic, then there's nothing you can do with it except incinerate, because it contains metals and other kind of components, which hampers with the pure polymer-based recycling. So then a method like pyrolysis is more likely, or if this solution actually becomes something more mainstream, then that would work as well. But thermomechanical, I don't see that happening. So that you have to keep it out of that waste processing.
Thank you very much. That was very detailed and very interesting.
Thank you. If there are no further questions, I think we can go back to you, Sarah.
Any questions? So Jin Sung Woo is available now, so he'll be presenting the talk now.
Apologies for the interruption. Could it be that you're still muted?
Yes, Dr. Jin Sung Woo, we can see the presentation.
Yes, sorry. Yeah, repeat. Yeah. Um, this talk about environmental sustainability and intelligence, as well as general green technologies. This the outline, and yeah, basically we have a number of part. Finally, we will talk about the general green technologies. First, we talk about the green challenge. In recent years, green challenge become more and more critical. And here, I feel the audience will familiar with such such a phenomenon. In 2023, UN Secretary Antonio Guterres say global warming has ended and the global boiling have arrived. That means doesn't say global warming no longer available. Just say the serious the situation arrive to global boiling. Yeah, this is flooding in Zhuozhou the suburb of Beijing, China. This Libya in 2023 flooding and also the high wind and the flooding. This Chongqing in China early July this year. 1,000 died. This Saudi America due to the high temperature weather. This show called the overshoot days. Overshoot days means this is a period, and how many portion the world use future for future generation resources. And you can say in early 1970, it's very little, but now becomes more and more challenging. This overshoot day by countries. For example, China here, it's China here is said May about June in the middle. That means half a year you use the future resources. Another issue is how to define green. We defined green much earlier. For example, 2021, we established HB technical subcommittee on green communication computing. We already have the definition. Basically, the sustainable and the union is friendly, and the green relevant to energy and resource, and also relevant to general sustainability. Another big trend is called the big data. This big data is appeared around 2000, and later on, different characteristics for big data was studied. But the main idea is they always have different feature, and big data also have many different varieties, different and no data have the unique feature the feature set. Due to the two big trend we studied, what the relation these two trend, big data and the green. And we have two paper. One paper called the greening big data. That means we discuss big data and the big data system, the green challenge and the issues in big data system itself. Yeah, this outline we used for discussion. Actually, we use life cycle of big data from generation storage to analytics. We propose a new metrics for big data error we first discuss the general definition of energy efficiency. This part in 1996 have for general definition. Actually, for ICT area, we most interesting about number two. And even more specific, this information base that divide the energy, and this number two subset of number two. And we define alpha. Alpha we call the important factor. Yeah, important factor means in big data error, the information base no longer equivalent. Some more important. That's why we define this alpha. And the information base divided by energy. This is the general definition, conventional. But this doesn't the conventional metric doesn't consider the difference of different information base. But in the we consider big data error, the information base have a different level of importance. We also have the similar definition for resource, that's called effective resource efficiency. The earlier I called effective energy efficiency. We have the different second paper talk about the big data towards green applications. Big data towards green application means we talk about the big data serve for different green applications. Certainly, here we do not specific to discuss green application as part of big data. This is the outline of the paper: environmental issue, energy management, and the general sustainability. Yeah, basically we would like discuss in more insight. First, we talk about the big data toward the green applications. But what the relation of AI toward the green applications? Actually, AI green AI makes sense. It's when big data coming. If the big data is small, green AI is not important. That means green AI in the trend is a subset of green big data. Thus, we discussed the general issue much earlier. Is in 2016. We discussed the general topic. Another topic called SDG. SDG is defined by United Nations in early 2000. Have another called MDG. MDG most is proposed for rich countries or developed countries. But the world, many countries, they are not rich. They are developing countries. In 2015, United Nations proposed SDG. You can see SDG have poverty, zero hunger. This is certainly is available for not rich countries. And this first classification for 17 goals. Yeah, and this paper in 2018. This is the first paper proposed the classification for the 17 goals. Yeah, and after our paper, a number of other classification also coming, but most is follow our approach, or there have some variations. By the way, we would like to say, SDG it's much highly underdeveloped. As we know, recently only 17% SDG on the track, but we only have what the SDG, the deadline. The deadline is 2030, only about 5 to 6 years, because 2025 already coming. Yeah, basically, this paper talk about SDG and ICT, and we after we have the classification, this is three group. Each group have two small group, and based on this group, we have details to discuss the relevance with ICT, and when we publish the paper, we found a number of goals have rarely developed for those goals relevant to ICT. For example, gender equality, no hunger, and certainly environmental sustainability have some already have some relevant applications. Yeah, here we show the big picture. Since we talk about intelligence and environmental, that's we have the term environmental intelligence, and this term actually is not new. Early 1996 have this term, but in early stage, they have different meaning. They mean security, because they proposed by the CIA officer. But later on, we talk about more general environmental issues. Another term called ambient intelligence. This is a subset of environmental intelligence. It's talk about the neighborhood of electronic environment. Yeah. Next, we talk about some cases. This one is about green IoT, green machine-to-machine communication under cellular networks, and in early stage, the 3GPP standard treat a machine and a human are the same in the stack, in the protocol stack, and we found that this should be treated differently. We propose the change of the protocol stack, and also one of the things I call the group ID, and we treat different from human. Machine can process grouply, and this concept later on widely used in 4G and 5G wireless standard. Here is the performance of proposal. Here, this one is talk about the green machine learning for cellular network, heterogeneous cellular networks. This is one of the pioneer use machine learning for wireless network traffic offloading. Yeah, this talk about the security issue for smart grid. Talk about false data injection. False data injection means some uh, by the intention to attack the grid. Use false data. Yeah, there's we use the reservoir computing DFN. Um, this is reservoir computing, and the reservoir computing means some neurals randomly connected at the reservoir. That's why, because random connected, that's why they can use less energy. And this is our proposal. You use DFN and multi-layer perceptions. The red line is our proposal. Have a robust performance to a different load of attack. Yeah, recently we have a paper called green building requirement feature life cycle relevant intelligent technologies. This paper just published. The basic idea is we first to uh, to discuss the requirement feature and life cycle. The, uh, we found that we do not found a good summary for this, and we have the summary. What the requirement for the green building, what the feature like, and also we consider like green building in terms of life cycle. One of the important that we discuss intelligent technologies. Yeah, this life cycle and also uh, this life cycle for the building. And we have the picture how intelligent technology can used in the green building. Yeah. Finally, we discussed general green technology. We earlier we talked about the green ICT or green information technologies, but based our experience, we found that green technology should be very general, not just about information technology. Many non-information technology, for example, chemistry, chemical engineering, civil engineering. Yeah, basically, this highly cross-disciplinary technologies. Yeah, we need to discuss the issues not limited by some area. Yeah, this is a basic concept of basic concept of what can be covered. We have a paper to discuss the general green technology. Yeah, thank you for any questions.
Thank you very much for your presentation. Any questions?
I make it very fast, because some details I didn't discuss. Yeah, this is the intelligent. We have the summary of intelligent machine learning, deep learning, reinforcement learning, fuzzy reasoning, genetics algorithms for the green buildings.
I hope there are no questions. We are moving on to next presentation by Hosna Gaurav
Okay.
from Concordia University, Canada.
Hello, can you hear me?
Yeah, I'm just making you the presenter.
Okay.
Yes, you can share the screen now.
Thank you. Can you see my screen? Oh,
Yes, we can see the screen. You can continue.
okay, thank you. Hello everyone, my name is Hosna Gora. I'm a master's student at Concordia University under supervision of Dr. Amin Hamad. And my research is about optimizing the reverse supply chain for deconstructed building components. At first, I'm going to talk about the problem statement of my research, then a review of the literature in this field, then I will talk about my proposed methods, and at the end, the contribution and what future works can be done in this field. The construction industry has followed the take, make, dispose approach for decades. This linear model has led to significant environmental issues. To put this into context, the construction industry is responsible for around 40% of global energy consumption and 30% of greenhouse gas emissions. Uh, it also consumes about 17% of fresh water and 25% of global wood. The circular economy aims to extend the life of materials through recycling them. Circular economy also aims to salvage the components by deconstruction and reuse. In construction, this means shifting our focus from demolition to careful deconstruction. The goal is to reclaim and reuse building components. Prefabricated construction is an emerged approach that supports circular economy principles by making disassembly easier. However, even with this approach, challenges remain. A circular model prioritizes longevity and adaptability, which will transform how materials and components are managed. However, due to the construction and reuse technical and economic challenges, the industry is not ready to accept these changes. Challenges such as technical issues in deconstruction because of the difficulties in separating components without damaging them, and the market is undeveloped for reused components, which is directly related to the imbalance between the supply and demand. This slide shows the specific challenges related to matching supply and demand, considering four aspects. The first aspect is location. The location of the building which will consume the reused components could be far from the location of the deconstructed building. The second challenge is time. The constructed components may not be available when required, leading to project delays. With respect to the time and location, the quantity of available components might not align with the needs of new projects, which may increase the storage costs. Quality is the next challenge. Reused components often lack the quality of new materials, limiting their applicability. And the last is function. Components may not meet specific requirements in terms of size or function, making them less suitable for reuse. This brings us to the concept of the reverse supply chain, which is key to managing deconstructed components. Unlike the traditional supply chain, the RSC involves collecting, refurbishing, and redistributing reclaimed components. However, despite the importance, the RSC in the deconstruction process remains underdeveloped. We need practical RSC models that can optimize the deconstruction practices to ensure that materials can have a second life. To answer to this problem, HOP is a space that does not exist in the current circular construction and can play the most important role in the proposed RSC. It is a place to prepare the components for their second life. Our research focused on two main objectives to address these challenges. Optimizing the RSC, we aim to minimize costs associated with the RSC through introducing a space as hub that will be used for sorting and storing and repairing in this model. And the second objective is optimizing hub functions. We seek to identify the best location for hubs that will facilitate activities like quality inspection, refurbishment of reclaimed components, and finally distributing to consumers. In this literature review, we explore how circular economy principles, reverse supply chain models, and advanced optimization techniques such as genetic algorithms and geographic information system apply to the deconstruction industry. Adopting circular economy principles helps extending material lifespan and reducing waste, as well as focusing on the reuse and recycling of building materials. One promising approach is the Building as Material Banks initiative, which used which uses a building material passport to document materials used in the construction. This digital passport tracks materials throughout the building's life cycle, making the construction easier and ensuring materials have potential for reuse in future construction projects. By adopting such practices, the construction industry can enhance material reuse and improve its overall sustainability. Um, The concept of circular economy has gained attention as an effective strategy for managing construction and demolition waste. The construction focused on salvaging materials for reuse, in contrast with traditional demolition. Although construction and demolition waste management is common, the construction introduced new approaches for more comprehensive reuse. A major challenge lies in the existing buildings, which were not designed for the construction. This limits the ability to integrate off-site construction during the dismantling phase. Looking ahead, the future of construction could overcome these challenges by adopting new building designs that prioritize modular construction, facilitating easier the construction and material reuse. This is all possible by an efficient reverse supply chain to unlock the sustainable resource recovery. The construction industry is starting to integrate a reverse supply chain that applies circular economy principles to manage CDW. Technologies like digital product passports support the process of the construction and reverse supply chain management by tracking individual components, making it easier and more practical. Um, the genetic algorithm was first introduced by John Holland and has since become a powerful tool for solving complex logistics and supply chain management problems. In circular deconstruction, GA optimized logistics by enhancing decision-making process. When integrated with geographic information system, GA offers better control over tracking reclaimed materials, improving the efficiency of the construction process. Additionally, combining GA with building information modeling provides a comprehensive view of the supply chain, supporting facility location optimization and promoting a more effective circular economy in the construction industry. As you can see in this slide, there are examples of different papers that how they utilize GIS and GA to locate the facilities and to track the flow of the items. The methodology centers around optimizing the hubs in the RSC. Hubs play a main role in bridging the gap between supply and demand by acting as a storage, quality testing, repair, and redistributing centers. Two key aspects are considered: the location of the hubs and their function. Optimizing their placement is crucial for minimizing transportation and servicing costs, and allocating functions effectively within each hub to ensure efficient preparation of reused components. A GA is used to identify the most cost-effective hub locations, addressing the challenge of balancing supply and demand efficiency. The flow of components and data across the five primary nodes is essential for managing the reverse supply chain. As it is shown in this slide, the five main nodes are the construction sites, hubs, recycle centers, factories, and end users. Data from BIM, GIS, and end users' requirements helps guide decisions at each step. BIM data assists in visualizing and planning the movement of items, while GIS data focus on geographic optimization, including transportation routes and locations. Taking Quebec province as an example, this figure highlights how the process of transporting through the five main nodes works. The arrows represent the flow of materials connecting various locations together. The flowchart outlines the decision-making process driven by the condition of the constructed components. The reverse supply chain process begins at the construction site, where components undergo a pre-quality test to determine their suitability for use. Demolished parts end up at recycle centers. If the parts are deconstructed instead of demolished and they are salvageable, they are transported to the hub for more precise quality control using more detailed quality test methods. More accurate inspection are provided at the hub for new arrival components for the final decision if they are capable of being reused or not. Further detailed inspection at the hub identifies the damaged parts and the amount of the damage. After the decision is made, if the component needs major repairs, they should be transported to the factory to be remanufactured. If not, they stay in the hub to be repaired and refurbished. Throughout the process, efficient inventory management is essential to handle the flow and storage of components. Finally, the prepared parts are distributed to the end users. Uh, Chromosomes structure of this model is like each chromosome represents a unique potential solution for the hub allocation problem. The structure of the chromosome allows us to encode the decisions about which hub will serve which nodes in RSC, like the construction sites, factories, recycle centers, and end users. The chromosome contains a number of genes equal to total number of 14 nodes in the RSC. For example, if we have 30 construction sites, 5 factories, 3 recycle centers, and 20 end users, the chromosomes would have 58 genes in total. Each gene corresponds to one of the 4 main nodes. The gene's value is an integer representing the index of the hub to which the node is assigned. The genes are organized in a specific sequence, as it is shown in this slide. The presented actual cost function is a core element of our RSC model. It aims to minimize the total cost involved at various stages, from transportation to operation within hubs and pre-quality tests, all the way to the construction and allocation of the hub. The key components are distance and transportation costs and operation costs, which is inside the hub, various processes like testing, refurbishing, and storage occur. And the hub construction costs, like the model consider the expense of building new hubs at optimal locations. Also, the component variables are CS, which represents the state of the components and materials after deconstructed at the site. SR determines if a component is repairable or unrepairable after arriving to the hub. SRM decides whether the component requires major repair, remanufacturing, or can be refurbished at the hub. Um, The constraints of the model includes the total weight of components from the construction site J must not exceed the capacity of hub K. The sum of hub capacities must be greater than the total weight from all the construction site loads. The loads from the construction site must be equal to summation of loads sent to the hubs, factories, and cycle centers. The total load received by end users must equal to sum of loads from hubs and factories. One end user can receive services from different hubs and factories. Some hubs services factories, some don't. Depends on the number of hub and factories. If number of factories are more than number of hubs, all hubs will service the factories. The loads that a factory sends to the end user is summation of what comes from recycle centers and the loads from hubs. Currently, I'm working on the result of this model, and I will publish them in the next publication. Um, the contribution of my work includes addressing gaps in the RSC of construction industry, integrating GA and GIS to identify optimal hub locations so to minimize costs, and hub functions which are quality inspection, refurbishing, storing, and redistributing. In the future work, we aim to develop specialized hubs to handle different types of components based on their material compositions, such as differentiate the hubs to concrete and steel special types. Another area of improvement is refining the generating algorithm methods, particularly in fitness evaluations, and exploring more advanced GA approaches. Lastly, one of the most promising direction is shifting focus from traditional construction to disassembly of modular construction. This process is not only easier but also more accurate, allowing for a more efficient and sustainable approach to material reuse and recycling in construction. Thank you. Any questions?
Thank you very much for your presentation. Any questions? I hope there are no questions. So we are moving on to next presentation by Jun Min Choi from Hansei University, South Korea. The title is Research and Development on Space Solar Power in Korea.
Can you see?
We can see your slides. You can start the talk.
Okay, you can see it, right?
Yes.
Okay. Okay, good afternoon, everyone. My name is Junmin Choi, and I'm currently working as an emeritus professor at the Hansa University in Korea after retiring from the Korea Aerospace Research Institute. Today, I will be presenting on the achievement which Korea has made in the research and development of space-based solar power. To briefly introduce space-based solar power for those who may not are familiar, it involves the constructing a solar power plant in space. In space-based solar power (SBSP) generation, as shown below, solar energy is first converted into electrical energy. This electrical energy is then converted into the electromagnetic waves and finally transformed back into electrical energy on Earth. The greatest advantage of SBSP is its ability to provide a continuous 24-hour power supply, which is not possible with conventional renewable energy sources. To demonstrate Korea's interest in SBSP to the international community, Korea held its first international workshop in 2017. The inaugural event was hosted at the National Assembly building with 2 members of parliament in attendance and participants from 3 different countries. The second international workshop was also held at the National Assembly building with participants from 5 countries and 4 members of the parliament in attendance. Among the attendees were the ruling party leaders and former presidential candidates. This slide shows the conceptual design of a 2 gigawatt Korean space solar power satellite. It has a mass of 10,000 tons and the dimensions of 2.2 kilometer by 6.8 kilometer. Now I will explain how the Korean space-based solar power satellite is constructed.
Hello, sorry for the interruption. Can you please change the slides? We are able to see your first slide only.
This one?
Please change the slides. We are able to see the first slide.
What do you see now?
First slide.
First one?
Yes.
You are looking, are you watching this one?
Yeah, first one.
And this one?
Yeah,
Can you see the
first
second?
one. You
Can you
need
see the
to
second?
click on the second one.
This is the second one, introduction.
But no, we cannot see the second one. We are seeing only the first one because first one is highlighted. Click on second
Really?
one. Just click on second one. We can see third slide now. Just click on the slide so that we can see the second one.
This is, let's see.
Place the cursor on second one so that we can see it.
This is the
Place it
second
on
one.
second one. Yes, now we can see the second one. Every time you need to place the cursor on the slide.
Okay. This is a
Now
third. This is fourth.
this is fourth. Yes, fourth
And
slide.
this is fifth.
Yes.
And then I'm going to show the video.
Yeah, this is sixth one.
So you can see the video?
Yes.
Okay. Now I'll explain how the Korean space-based solar power satellite is constructed. First, the module representing the headquarters is launched into low Earth orbit instead of a geostationary orbit. Lightweight truss structure extends from the both sides of the helicopter module with additional truss attached as needed. This modular design allows for each scaling up or down based on a development budget. Once the main structure is complete, a vertical framework for installing the solar panels installed. After all the frameworks are set up, the Space Shuttle delivers the solar panels for installation. The solar panels are designed in a flexible rollout type. Using the robotic arms attached to the Space Shuttle, these rollout solar panels are installed onto the framework. A total of 4,000 rollout solar panels needed to be installed. After solar panels are fully installed, the power transmission antenna is assembled. The central antenna module unfolds, and the additional antenna modules are connected to it, creating the desired size of a power transmission antenna. We are currently considering a square-shaped antenna with a length of 1 kilometer. Once the satellite is fully assembled, a portion of the solar panels will be deployed for generating electricity required for performance testing. After verifying performance in the low Earth orbit, the satellite will transit to the geostationary orbit using electrical propulsion, which utilize abundant electrical power. The reason for not fully deploying the solar panel during this transition is to reduce the risk of a collision with the space debris. Once the satellite reaches the target orbit, all the solar panels will be fully deployed to generate power. On the Earth, on the moon, on the ground, the power will be integrated to the power grid to provide a stable 24-hour power supply. A space-based solar power satellite can be installed in necessary quantities. Providing power not only to the Earth but also to the settlements on the Moon and Mars, supplying energy to future inhabitants. The demilitarized zone, DMZ, between South and North Korea is proposed as a potential location for rectennas. Rectenna means the reception antennas. If a DMZ is filled with rectennas, both the South and North Korea would not have to worry about electricity for a considerable time. The total weight of space debris currently orbiting Earth is estimated to be around 9,000 tons. Since a single space solar power satellite can weigh up to 10,000 tons, its disposal after the end of the mission poses a significant challenge. For geostationary orbit satellite, the current method is to move them to the graveyard orbit. However, this approach is not a fundamental solution to the problem. In 2021, Korea proposed an ultimate solution for space solar power satellite disposal, which involves sending the mega structure into lunar orbit and collide it with the lunar surface. This approach can be referred to as the lunar deorbit. To execute this maneuver, the final approach vector must align with either ascending or descending node of the Moon. The figure on the left shows the trajectory of a KSSPS disposal in geocentric inertial coordinate, while the figure on the right illustrates the same trajectory and the Earth-Moon rotating frame, where the Moon is always positioned at the top of the orbit. Let's take a look at the Korean Space Solar Power Satellite, which has a mass of 10,000 tons. For a hard landing on the Moon from GEO, GEO means geostationary orbit, 180 tons of propellant are required for the disposal of the KSSPS. This slide summarized the number of orbits and the total time required for KSSPS disposal, depending on the thrust force. The process will take at least 13 months. Coincidentally, it turns out I'm not the only one who considered the lunar deorbit. The Mother Nature took action just 1 year after my proposal. On March 4th, 2022, Mother Nature disposed of the Chang'e 5 T1 booster, which was launched in 2014, by impacting it on the lunar surface. In 2022, Korea proposed a pilot system for demonstrating space-based solar power using two small satellites in formation flight in low Earth orbit. One satellite serves as a power transmission unit, while the other functions as the power reception unit. Two satellites have nearly identical shapes. Each satellite has a mass of 120 kilograms. This video demonstrates how two satellites transmit and receive power in space. The launch site is Naro Space Center in Korea. First, the satellite protective fairing is jettisoned and the power transmission satellite separate. Next, the power reception satellite also separate. The transmission satellite first deployed its solar panels, followed by deployment of a transmission antenna in 2 stages. To establish communication with the ground station, it needs a clear view of the S-band antenna. It's achieved by using a boom made of shape memory material. The satellite aligns its solar panel perpendicular to the sunlight to fully charge the battery. Afterward, a transmission satellite uses its thruster to approach the location of a reception satellite. The reception satellite changes its orientation by 180 degrees. A laser beam is emitted from the transmission antenna to precisely measure the distance between two satellites. The reception antenna also emits a laser beam to measure not only the distance but also the alignment between antennas. A pilot signal is sent from the reception antenna to the transmission antenna, indicating its direction. The transmission antenna then broadly radiates power towards the reception antenna. The channel of the transmission antenna are calibrated. After calibration, a transmission antenna focuses the power sharply toward the reception antenna. The transmission and the reception antenna are then synchronized, enabling precise beam steering. The transmission antenna adopts a sun pointing orientation to charge the batteries, while the reception satellite carry out the observation of a scientific mission. Next goal is to demonstrate the power transmission between satellite in low Earth orbit and the ground. When the power transmission is not possible, the satellite will continue with the observation of a scientific mission. Of course, the ultimate goal is to transmit power from geostationary orbit to Earth. In 2023, Korea proposed a method to recover significant electrical power from low Earth orbit using a medium-sized satellite with a mass of less than 1,000 kilograms. The power transmission antenna expands to 10 meter by 10 meter in orbit. A medium-sized satellite weighing 978 kilograms is launched into the low Earth orbit. At launch, the transmission antenna is positioned upward, but once it reaches its mission orbit, the antenna will point toward the Earth. Like other satellite, the solar panels are deployed first. Since a large number of power is required, it has 10 solar panels. To ensure the communication with the ground station, S-band antenna needs a clear line of sight, which is achieved using a boom made of shape memory material. This time, a double layered boom is used. Next, the transition antenna is deployed. The transmission antenna measured 10 meter by 10 meter and consists of 100 sub-panels. A ground-based reception antenna emits a pilot signal to the transmission antenna indicating its direction. The transmission antenna then calibrates its reference channel using ground data, and based on this reference, adjusts the other channels on the transmission antenna. Once the calibration is complete, the transmission antenna accurately directs power to the ground-based reception antenna. Reception antenna can be either a reflector antenna or cluster of dipole antennas. Research has shown that in a low Earth orbit, reflector antenna performs more effectively. In the normal design, transmission antenna and the solar panel needs to be very large to recover electrical power on the ground. However, this approach demands a massive budget and presents a significant challenge in managing the satellite. To address these issues, supercapacitors were used instead of batteries, enabling the transmission antenna to consume 500 kilowatt and generate an RF output of 180 kilowatt. This design allows for the recovery of electrical energy on the ground through high power output, eliminating the need for a massive structure. These are the specifications of the satellite. It has a mass of less than 1,000 kilogram and the dimensions of 1.7 by 2.1 by 3.1 meters at the launch, expanding to 21.9 by 18.5 by 3.9 meter in orbit. With this design, it is expected that 29.5 watts of power can be recovered on the ground from the satellite at an altitude of 400 kilometers, despite the low efficiency. Although the wireless power transmission WPT is essential for space-based solar power, testing it over long distance on the ground is challenging. This is particularly difficult in Korea due to strict electromagnetic wave regulation caused by the dense population and the limited research budget. Despite this constraint, Korea successfully conducted a long-range WPT test in a cost-effective manner at the end of 2023. These four photos represent a significant milestone in the history of wireless transmission. In 1975, Bill Brown of Raytheon and Richard Dickinson of NASA conducted the first successful demonstration of wireless power transmission, achieving the largest power recovery in history, that is 34 kilowatts over a distance of 1.55 kilometers. In 2008, John Mankins undertook a challenging experiment in Hawaii, transmitting power wirelessly over a distance of 148 kilometers. In 2022, the U.S. Naval Research Laboratory reported recovering 1.6 kilowatt of power over a distance of 1 kilometer using pulsed microwave sources instead of continuous wave sources. In May of 2023, Caltech detected a microwave signal transmitted from the space at the altitude of 480 kilometers from the ground. In Korea, we utilize the 5 key elements to conduct the WPT in a cost-effective manner. First one is a 35-meter diameter Korea deep space antenna. Second one is a rectangle measuring 9 by 9 centimeter and weighing 3.6 kilogram. Third one is a steering device for controlling the rectangle angle. Fourth one is aerostat. It's similar to helium balloon. Fifth one is a 55-meter ladder truck. We use an aerostat to elevate the rectangle for testing in challenging geographic areas. After we were fortunately enough to find a small plateau on a hill, the 55-meter ladder truck serves as a test platform. The test was broadcast nationwide. This video will help you understand how the test was conducted, even though it is in Korea. It says the success of a 1.8 kilometer WPT. This is the first step toward SBSP. They are installing the antenna on the aerostat.
연구원들이 비행선 밑에 장착하는 건 LED 전구가 달린 전력 수신 장치. 준비를 마친 비행선이 서서히 고도를 높여가고 1.8km 떨어진 곳에서
The Korea deep space antenna is transmitting 2.3 kilowatt of power toward the aerostat.
2W의 전력을 우선으로 전송합니다. 그 순간 비행선의 수신 장치에서
LED lamps lights up after rectifying the power.
시무전 안테나에서 전파를 쏘면은 이 안테나로 전파를 받아서 직류로 변환을 하고요. 그 직류도 변환된 전기로 여기 보이시는 LED에 불이 들어오는 겁니다.
우선으로
This is
전력을
the
수신하는 실험은
1975 test.
미국에서 처음 이루어졌습니다. 당시 거리는 1.5km. 이번에 우리 연구진이 이 기록을 뛰어넘은
This is the new record in this
우선 전력
test.
송수신에 성공한 겁니다. 우선으로 전력
These are the achievements from the test. For the first time, Korea's 35-meter deep space antenna, originally used for the lunar orbiter Danuri, was repurposed during non-operating hours. The second one is the aerostat was effectively used to overcome geographical barriers. Third one is the combination of a ladder truck and multi-stage LED illumination was proven to be the most cost-effective method for long-range test. Fourth one is the successful visualization of power retrieval over a distance of 1.82 km was achieved by capturing the illumination of LED lamps. Fifth one is after several upgrades, it is expected that more than 20 times the current power will be recovered by the end of 2024. The last one is this study serves as a promising foundational step toward the future effort to advance long-range wireless power transmission efficiently and cost-effectively. Here is the summary of Korea's SBSP R&D efforts. Despite Korea's relatively late start in R&D for SBSP, the country has made notable progress in this field. Key achievements include the release of conceptual design for Korean space solar power satellite, and the proposal of a disposal method for SSPS. The development of a pilot systems conceptual design for space-based solar power utilizing 2 satellites in formation flight. The last one is a creation of a low Earth orbit space-based space solar power system. And the Korea has also succeeded in the recovering electrical power through wireless power transmission at the record distance of 1.82 km. The proposed disposal method, which involves impacting space solar power satellite on the lunar surface, could be the most effective solution for space debris disposal. This method could potentially be applied to disposal of all geostationary orbit satellites in the long run. Given that space-based solar power can provide a reliable base load power with a 24-hour power supply, it is essential to commercialize the technology after overcoming the current challenges. Thank you very much. Any question? Sarah, seems like no question.
Thank you very much for your presentation. Any questions?
Okay, I closed my video.
I hope there are no questions. So we are moving on to next presentation by Paresh Kumar Sharma from Bangladesh Agricultural University, Bangladesh. The presentation title is Understanding Dairy Livestock Farmers' Intention to Adopt Socio-Cultural Dynamics for Food Security Using the Theory of Plant Behavior.
I want to share my slide.
You have logged in from two devices. Can you please log out from one device because there is an audio issue?
I cannot share my slide.
You have logged in from two devices. Can you log out from one? We can see two logins from your side.
I cannot see where I log into device. Okay.
Okay, do one thing. You just sign out and sign in again. Are you there? Click on the share button.
On my laptop, I cannot share my presentation. I sent my presentation in my WhatsApp. Can you share this presentation?
You can share from the laptop because I have made you the presenter already. You can see the share button right in the middle. Mic, camera, share. Yes. And go to the first slide. We can see the presentation. Just you need to go to the first slide.
Can you share? Can you see my slide?
Yes, we can see the slides.
Hello.
Just yes, we can see the slides. Just go to the first slide.
Hello.
Hello. We can see the slides.
Hello.
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 We can see the slides. You can start the presentation.
I am Dr. Paresh Kumar Sharma from Bangladesh Agriculture University Research System. This is Coalesce Bowres. The Bowres is the operating all academic research project from my agriculture university. I am working there as a senior scientific officer. My presentation title is Understanding Dairy Livestock Farmers Intention to Adapt uh, Sociocultural Dynamics for Food Security using the Theory of Plant Behavior. Uh, Background of the study, the socioeconomic cultural dynamics comprehends belief, attitude, social structure, significant shape and decision making process and practice of livestock farming household, affecting their adapt sustainability, intervention in food security. Impact on food security, socio-cultural dynamics play a crucial roles in various aspects on food security, including uh, food availability, access, utilizations, and stability, particularly in resource poor and marginal communities. Cultural appearance and policies, understanding socio-cultural dynamics is essential. Developing the culturally appropriate policies and intervention align the local values and practice. They are enhancing food security, resilience, livestock farming household. The role of social network, community social network facilitate the flow of information and resource, which are crucial for adopting sustainable farming practice and improving food security in dairy farming household. interaction the external factors, the socioeconomic dynamics, uh, improving food security, need to cultural intensive intervention, uh, developing culturally appropriate policies and intervention that respect and incorporated local tradition and beliefs is essential for promoting sustainable livestock farming household and improving food security. uh, Research gap. Despite the knowledge uh, none of appropriate socio-cultural dynamics, there is a research gap in understanding its specific impact on livestock farming household in Bangladesh. This study aims to fulfill the gap, explore the how cultural factor influence farming practice and food security, contributing the development effective culturally sensitive uh, and uh, aligned with socio uh, economic principles. Uh, why this study is associated with this circular economy? The association with circular economy, this resource efficiency, dairy farming, sustainable practice, and community engagement networks. Uh, the research objectives are to investigate how the social cultural dynamic influence the adaptation of dairy farming practice and impact of food security, to examine the causal relationship between socio-cultural dynamics and food security in uh, dairy farming household, and to explore, um, third is uh, explore the strategic sociocultural practice into the policies promote sustainable dairy farming and for food security. Overall, this study explores how integrating sociocultural dynamics into dairy farming can support food and nutritional security while aligned with circular economic principles. By promoting resource efficiency, sustainable practice, and strong community network, dairy farming household can adopt practice that contribute to a circular economy, enhance the resilience and sustainability of their food system. The methodology of this study, the target population of this study is dairy farming household. Uh, the sampling technique, stratified random sampling technique has been used to obtain 384 household. Uh, Direct interview method and structured pre-testing questionnaire has been used to survey. Key informative interview, focus group discussion, and the data analysis has been conducted by descriptive statistics, inferential statistics, propensity score matrix, and partial least square SAM matrix, partial multi-group analysis. Uh, the study area is Raspberry districts of Bangladesh, considered three sub-districts, and sample size was determined the following formula. Here, 384 samples were collected from this study area. Uh, the data analysis techniques, uh, the Kaiser, Mayor, Olkin, and Sapario were used to evaluate the structure of indicating adequacy of questionnaire is meaning the construct. This study applies the theory of plant behavior, theoretical framework, as well as partial least square equation modeling to adaptation of sociocultural dynamics for food security. This flowing econometrics equation will be applied to reach the final objectives. Uh, the modified theory of plant behavior, here is the conceptual framework, and behind this side we produce five hypotheses to accept my research objectives. Uh, the uh, our key findings of our research, the sample accuracy test. Here, there are 5 constructs: cultural values and beliefs, the vertical KMO measure, sample accuracy score is 0.5407, and Bartlett separator test p-value is significant. And another construct is subjective norms. This KMO measure sampling accuracy is 0.7893, and Bartlett separator test is p-value is significant at 1% level. It meaning that the sample accuracy has been obtained in this study. The community and social networking constructs also same, and perceived behavior control also significant at Bartlett superior test. This table indicates that our sample accuracy is suitable for this study. Uh, this slide shows the association between the constructs and the background of the variables. Here, the socioeconomic variables, and there are 4 constructs. Most of the socioeconomic variables are uh, positively significant with our construct. Our 6 constructs obtained the Likert scale questionnaire. First is the behavior, intention, socio-cultural dynamics is determined by 5 indicators, 5 observations, which is come from 5 scale Likert scale questionnaire. Here, Corvus alpha is 0.802. It meaning that the uh, Corvus alpha's value indicate strong internal consistency because it greater than 0.5. Our Corvus alpha value is 0 to 1. Is near to 1 indicate the internal consistency of this our observation is suitable. Another construct is consumption, communication, and social network. Uh, this construct is developed 3 observation, which is come from 5 level like a scale question. Here, Corvus alpha was 0.7 to 6, which is the greater than 0.5. It also same here. Another is behavior, perceived behavior control analysis construct related to community in the interaction, government relations, and teamwork of dairy farming practice. This uh, implication of the intervention inside the construct guide, tailor intervention emphasis cultural insensitive and sustainable practice and collaborative approaches for enhancing food and nutritional security. Reliability and validity test of these constructs here, Corvus alpha, composite reliability, and average variance extracted. Here, the importance of validity and reliability, uh, critical concept in measurement, ensuring that instruction in social science are both accurate, validity, and consistency, reliability. Measurement metrics, this table indicate the Corvus alpha and composite reliability and average variance extracted are assessing the ability, variable availability, and reliability of the construct. Corvus alpha, this matrix evaluate internal consistency with the constants with higher value indicated stronger reliability. Here, BISCD has alpha is 0.802, showing good consistency. Composite reliability value above 0.7 are considered acceptable, reflecting the reliability of construct across the multiple indicating average constants. The measure the variance captured by the construct relatives and measure error with the value like 0.541 for BISCD, indicating substantial variance capture supporting the robustness of the research findings. Another test is Forner-Lackett criteria. Is a method introduced by Cornell and Lackett in 1981 access discriminator validity the structural equation manner. Proposed the my structural equation model criteria compared the square root of average variance extract AVE for each construct is correlated between the constructs and other measure distinctiveness. Application of this test study, the among the latent variables focusing on socio-cultural dynamics and food and nutrition security in dairy farming household. Each construct should be greater than correlation and other constructs indicating strong discriminatory variable. The Cornell Lacker criteria of this table, all constructs of study measure unique aspects supporting the model discriminant variable. Another is HTMT test is a key indicator of discriminant validity reflective constructs are studied. Here, the ratio correlation was the relation between different constructs. Here, BI, SCDC, SN, CB, FNS, and PBC, SN to ensure the distinct. The HTML values below the cut of 0.90 confirm the constructs are not highly correlated, indicating the strong discriminated validity. Comparison with the Forner Lackard and HTML introduced by the Hanseler et al. In 2015 offered the most robustness approach evaluating discriminated validity compared the Forner Carter criteria. This HTML result derived using smart PLS demonstrated that all constructs have discriminated validity supporting the static measurement model. The R square value is 0.128 of BIS CD and 0.853 for FNS for this study construct model. R square measures variances dependent variable explained by the independent variable. The R square value 0.353 indicate the substantial impact of socio-cultural dynamics on food and nutritional security. An R square of 0.128 BICD suggested moderate influence the study's constructs. Higher R square reflect a better fit, highlighting the significant role of socio-cultural dynamics in dairy farming household. The goodness of this model is evaluate how well the hypothesis model fit the observed data structure equation model. Here the SRMR, the indicator is 0.078 and chi-square is 1121.599 indicate good model of fit. And ULS value 1.266 and UD value is 0.46 and suggest accurate model representatives. And NFI is 0.718 confirm the model is accurate potential sample size effect. This hypothesis test here the BISN and association to FNS, the path coefficient show a positive relationship between the personal values and beliefs and adaptation of socio-cultural dynamics, as well as food and nutritional security in dairy farming household. The T value is 1% level of significant indicate that this relation is statistically significant. And CNS and BISCD, this path coefficient between community engagement and personal values and beliefs, as well as adaptation of socio-cultural dynamic, demonstrate a positive relationship. And at 1% level significance suggests that community interaction has a significant influence on adaptation behavior. And third one is relationship between integrated cultural value and beliefs into modern dairy farming practice and personal values and beliefs is positive, but not significant, statistically significant. And PBCBI SCD, this path coefficient between perceived behavior control and personal values and beliefs is positive with a t value of 2.378 and a 5% level of significance. And SNBISCD, this path coefficient between social network and personal values and beliefs is positive but not statistically significant. This result conclusion and policy forward. This first of all influence the socio-cultural dynamic. This study highlighted the significant impact on socio-cultural dynamics on household food security and livestock farming household, emphasizes that the importance of cultural norms and beliefs for food security. Uh, and theory of plant behavior insight. Using the theory of plant behavior, the research reveals a positive association between sociocultural dynamics and food security, particularly through the behavior intention sociocultural dynamics. Uh, for policy implication, policymakers should incorporate sociocultural consideration into strategies to enhance food security in dairy farming household, tailoring intervention the specific community needs. Need to policy makers for further taking program to ensure food security. Sustainability agriculture practice, considering this point, understanding the cultural significance of livestock and its role of wealth and social structure is a crucial in developing sustainable food security strategies and future strategies and the effective intervention must interact cultural values, social norms, and community exceptions to ensure long-term resilience and sustainable food security effect. Thank you all for patient hearing. Have any question?
Thank you very much for your presentation. Any questions? I hope there are no
Thanks for any
questions.
question.
I hope there are no questions. I thank each and everyone for joining the webinar, and you have made it a successful one. All the presentations are really informative and we really enjoyed it. Thank you one and all. I'll be sending you the certificates in next 10 minutes. Please go through the mail and just check the certificate and book. If any corrections, let me know through the mail. Thank you. Have a great day. Bye bye.